The solar system is filled with wonders that challenge our imagination and defy our expectations. From planets that rain diamonds to moons with oceans deeper than Earth's. Prepare to have your mind expanded by 100 facts that sound impossible, but are absolutely true. Fact 1. The sun contains almost everything. When you look up at the night sky and see the planets, moons, and stars, you might think the solar system is full of massive objects scattered throughout space. But here's something that will change your perspective forever. The sun makes up 99.86% of the solar system's total mass. Think about that for a moment. Everything else, every single planet, every moon orbiting those planets, every asteroid tumbling through space, every comet streaking across the darkness, all of it combined accounts for less than 1% of the solar system's mass. The sun is so dominant, so overwhelmingly massive, that everything else is essentially a rounding error. Jupiter, the largest planet, seems enormous to us, but even Jupiter is just a tiny fraction compared to our star. All 8 planets together, along with their moons, the asteroid belt, the Kuiper belt, and everything else we can see or detect, amounts to almost nothing when measured against the sun. This incredible imbalance shows us just how central the sun is to our solar system, not just as a source of light and heat, but as the gravitational anchor that holds everything in its orbit. Fact 2. Neutron stars have unimaginable density. Imagine picking up a teaspoon, the kind you use to stir your morning coffee. Now imagine that teaspoon could hold 10 million tons of matter. This isn't science fiction, this is the reality of neutron stars. While neutron stars don't exist in our solar system, they represent one of the most extreme forms of matter in the universe. And understanding them helps us appreciate just how strange matter can become under extreme conditions. A neutron star is what remains after a massive star explodes in a supernova. The core collapses so completely that protons and electrons are crushed together to form neutrons, creating matter so dense that a single teaspoon weighs about 10 million tons. To put this in perspective, that's roughly equivalent to 900 Great Pyramids of Giza compressed into a volume smaller than a sugar cube. The density is so extreme that if you could somehow bring a teaspoon of neutron star material to Earth, it would instantly sink through the planet, pulled by its own immense gravity. The atoms are packed so tightly that there's essentially no empty space left between them. This mind-bending density shows us that matter can exist in states far beyond our everyday experience. Fact 3. The solar system has a tail. You probably learned in school that the solar system consists of the sun at the center, with planets orbiting around it in roughly circular paths. But what you might not know is that the entire solar system has a tail, much like a comet. As our solar system moves through the Milky Way galaxy, it plows through the interstellar medium, the thin gas and dust that exists between stars. This creates a boundary where the solar wind, the stream of charged particles flowing out from the sun, meets the interstellar medium. Behind us, trailing in the direction opposite to our motion through the galaxy, there's a tail called the heliotail. What makes this even more fascinating is the shape of this tail. Scientists have discovered that the heliotail is shaped like a 4-leaf clover. This unusual shape forms because of the way the solar wind interacts with the magnetic fields in interstellar space. The tail extends for billions of miles behind us, marking our path through the galaxy like a cosmic contrail. This discovery reminds us that our solar system isn't a static island in space, but a dynamic structure moving through the galaxy, leaving its mark as it travels. Fact 4. Space tsunamis crash through Earth's magnetic field. When you think of tsunamis, you probably picture massive waves of water devastating coastal areas. But there are tsunamis in space too, and they're equally dramatic. When the sun releases a large solar flare or coronal mass ejection, billions of tons of plasma and magnetic field explode away from the sun at millions of miles per hour. When this plasma reaches Earth, it slams into our planet's magnetic field, creating gigantic rolling waves in the magnetosphere. These space tsunamis can be larger than Earth itself, rippling through the protective magnetic bubble that surrounds our planet. Unlike ocean tsunamis that last minutes or hours, space tsunamis can persist for much longer, sending waves of energy cascading through the magnetosphere. These waves can interfere with satellites, disrupt radio communications, and even cause power grid failures on Earth's surface. During major space weather events, these magnetic tsunamis can compress Earth's magnetosphere so dramatically that the protective boundary comes much closer to our planet's surface than normal. Fortunately, our magnetic field is strong enough to protect us from most of the harmful effects. But these space tsunamis remind us that Earth exists in a dynamic and sometimes violent cosmic environment. Fact 5. The solar wind fills. Space is often called a vacuum, and technically that's true, but it's not completely empty. The entire solar system is filled with something called the solar wind, a constant stream of charged particles flowing out from the sun in all directions. Every second, the sun loses about 6 million tons of material through the solar wind. These particles, mostly protons and electrons, stream outward at speeds between 300 and 800 kilometers per second. The solar wind carries the sun's magnetic field with it, creating a vast magnetic bubble called the heliosphere that extends far beyond the orbit of Pluto. This constant outflow of particles creates what we might think of as space weather, affecting everything from the orbits of comets to the operation of spacecraft. When the solar wind reaches Earth, it interacts with our magnetic field, channeling particles toward the poles where they create the beautiful auroras we call the northern and southern lights. The solar wind continues outward until it finally meets the interstellar medium, where the pressure from outside finally balances the outward pressure from the sun. This happens at a distance of over 11 billion miles from the sun, marking the edge of the sun's direct influence. Fact 6. The sun has no surface to stand on. If you could somehow survive the heat and radiation, could you land on the sun? The answer is no, and not just because of the temperature. The sun doesn't have a solid surface at all. What we see when we look at the sun, that bright yellow disk in the sky, is just the visible layer of a vast ball of superheated plasma. Plasma is matter so hot that electrons are stripped away from atoms, creating an ionized gas that behaves very differently from the gases we're familiar with on Earth. As you descended into the sun, you wouldn't encounter a surface where you could stand. Instead, you would pass through layers of increasingly dense and hot plasma. The sun is essentially a giant ball of hydrogen and helium gas held together by its own gravity and heated to incredible temperatures by nuclear fusion in its core. There's no point where gas transitions to solid, no ground beneath the glowing surface. If you somehow tried to land on the sun, you would simply sink deeper and deeper into increasingly dense plasma until you were vaporized by the intense heat. This fundamental difference between the sun and the rocky planets reminds us that stars are entirely different types of objects. Fact 7. The corona is hotter than the surface. Here's a puzzle that has confused scientists for decades. The sun's core, where nuclear fusion occurs, reaches temperatures of about 27 million degrees Fahrenheit. As you move outward from the core, the temperature decreases, which makes sense because you're moving away from the heat source. The visible surface of the sun, called the photosphere, is a relatively cool 11,000 degrees Fahrenheit. But here's where it gets weird. The sun's outer atmosphere, called the corona, which extends millions of miles above the surface, somehow reaches temperatures of several million degrees Fahrenheit. How can the outer atmosphere be hundreds of times hotter than the surface below it? This is called the coronal heating problem, and it defies our normal understanding of heat flow. Heat should flow from hot regions to cool regions, not the other way around. Scientists believe the answer lies in the sun's magnetic field. The magnetic field lines that extend through the corona can store enormous amounts of energy, and when these field lines reconnect and release their energy, they can heat the surrounding plasma to extreme temperatures, but the exact mechanisms are still being studied. This mystery reminds us that even our closest star still holds secrets we're working to understand. Fact 8. 1 million asteroids weigh less than the Moon. The asteroid belt between Mars and Jupiter sounds crowded and dangerous. Movies often show spaceships dodging asteroids in dense fields, narrowly avoiding collisions at every turn. In reality, the asteroid belt is mostly empty space, and here's something even more surprising about those asteroids. There are more than 1 million asteroids in our solar system that we know about, with millions more that are too small to detect. Despite this huge number, the total mass of all asteroids combined is less than the mass of Earth's moon. The moon has a mass of about 73 billion trillion kilograms. All the asteroids in the solar system together add up to less than that. Even Ceres, the largest object in the asteroid belt, and now classified as a dwarf planet, contains only about 1/3 of the total mass of all asteroids. Most asteroids are small, just rocks tumbling through space. The average distance between asteroids is so large that if you were standing on one asteroid, you probably wouldn't be able to see another one without a telescope. This shows us that space is truly vast, and even regions we think of as crowded are actually mostly empty. Fact 9. The Oort cloud is unimaginably distant. If you think Pluto is far away, wait until you hear about the Oort cloud. The Oort cloud is a theoretical shell of icy objects that surrounds the entire solar system like a giant bubble. We call it theoretical because we've never actually seen it directly. We know it must exist because long-period comets, the ones that take thousands or millions of years to orbit the Sun, must come from somewhere, and their orbits suggest they originate from this distant region. The inner edge of the Oort cloud is estimated to be about 2,000 times farther from the Sun than Earth is. To put this in perspective, Earth is about 93 million miles from the Sun. Pluto, at its most distant, is about 40 times farther away than Earth. But the inner edge of the Oort cloud is about 2,000 times Earth's distance, and the outer edge might extend halfway to the nearest star. At these distances, the Sun would appear as just a bright star in the sky, barely distinguishable from other stars. An object in the Oort cloud takes millions of years to complete a single orbit around the Sun. This vast, icy shell represents the true extent of the Sun's gravitational influence. Fact 10. Space dust constantly rains down on Earth every single day. Earth is bombarded by debris from space. This isn't a cause for alarm because most of this debris is tiny, but the sheer amount is staggering. Approximately 100 tons of interplanetary dust and sand-sized particles fall onto Earth every single day. That's about the weight of 200,000 pounds of material, mostly in the form of tiny particles that burn up in the atmosphere as meteors or drift gently down to the surface. Over the course of a year, Earth gains about 36,500 tons of mass from space dust. Most of these particles are remnants of comets and asteroids, small pieces that have broken off and spread throughout the solar system. When Earth's orbit intersects these streams of debris, we see meteor showers as the particles burn up in our atmosphere. Some particles are so small they don't burn up at all but drift down through the atmosphere and settle on the ground. You've probably breathed in space dust at some point in your life, or touched surfaces covered with microscopic particles from asteroids that exploded millions of years ago. This constant rain of cosmic material connects us to the broader solar system, reminding us that Earth isn't isolated but part of a dynamic system. Fact 11. Mercury's day is longer than its year. Mercury is the closest planet to the Sun, and because of this proximity, some strange things happen with its rotation and orbit. Here's something that seems impossible but is absolutely true. A day on Mercury, the time it takes for the planet to rotate once on its axis, is longer than a year on Mercury, the time it takes to orbit the Sun. Mercury takes 59 Earth days to complete one full rotation, but it only takes 88 Earth days to orbit the Sun. How can a day be longer than a year? The answer lies in Mercury's slow rotation and quick orbit. Because Mercury is so close to the Sun, it orbits quickly, whipping around in just 88 Earth days. But it rotates on its axis very slowly, taking 59 Earth days for one complete spin. This creates a bizarre situation where Mercury completes almost 1.5 orbits around the Sun in the time it takes to rotate once. If you were standing on Mercury's surface, you would experience an incredibly long day-night cycle. The Sun would rise, slowly crawl across the sky over the course of many Earth weeks, set, and then you'd experience an equally long night before the Sun rose again. This odd relationship between Mercury's day and year is unique in the solar system. Fact 12. Venus is the hottest planet. Despite being second from the Sun, logic would suggest that Mercury, being closest to the Sun, would be the hottest planet in the solar system. But logic doesn't always apply in space. Venus, the second planet from the Sun, is actually the hottest planet, with surface temperatures reaching about 870 degrees Fahrenheit. That's hot enough to melt lead. How is Venus hotter than Mercury when it's farther from the Sun? The answer is Venus's thick atmosphere and runaway greenhouse effect. Venus is wrapped in a dense atmosphere composed mostly of carbon dioxide, with clouds of sulfuric acid. This atmosphere is so thick that the surface pressure is 92 times greater than Earth's, equivalent to being 3,000 feet deep in the ocean. The carbon dioxide traps heat so efficiently that Venus became a furnace. Sunlight passes through the atmosphere and warms the surface, but the infrared radiation that would normally carry heat back into space is trapped by the carbon dioxide. Over time, this greenhouse effect became so extreme that Venus's surface temperature soared to levels that make the planet uninhabitable. Mercury, despite being closer to the Sun, has almost no atmosphere to trap heat, so its night side becomes extremely cold. Venus teaches us how powerful greenhouse effects can be. Fact 13. Mercury is shrinking. When you think of planets, you probably imagine them as stable, unchanging worlds that have looked the same for billions of years. But Mercury is actually shrinking. As Mercury's massive iron core slowly cools over geological time, the planet contracts. This contraction has created enormous cliff-like features called scarps that crisscross Mercury's surface. These scarps are thrust faults, places where one section of the crust has been pushed up and over another section as the planet shrinks. Some of these cliffs are hundreds of miles long and over a mile high. They're evidence of Mercury's interior slowly cooling and contracting, causing the planet's crust to wrinkle and fold like a grape turning into a raisin. Scientists estimate that Mercury's radius has decreased by about 7 kilometers over the past 4 billion years. That might not sound like much, but it represents a significant change in the planet's overall size. The process is still ongoing, though at an incredibly slow rate. Over millions of years, Mercury will continue to cool and shrink, creating new scarps and modifying its surface. This ongoing geological activity reminds us that planets aren't static objects, but dynamic worlds that continue to evolve over time. Fact 14. The Sun can rise twice on Mercury if standing on Mercury wasn't strange enough already with its long days and extreme temperatures. Here's something that would truly boggle your mind. From certain locations on Mercury's surface, you could watch the Sun rise, stop in the sky, reverse direction, and set again, then rise once more. This bizarre phenomenon results from Mercury's unusual combination of its orbit and rotation. Mercury has a highly elliptical orbit, meaning its distance from the Sun varies significantly as it travels around. Mercury also has a slow rotation that's tidally locked in a 3-to-2 resonance with its orbit. This means Mercury rotates 3 times for every 2 orbits around the Sun. At certain points in Mercury's orbit, particularly around perihelion, when Mercury is moving fastest in its orbit, the orbital motion temporarily exceeds the rotational motion. From the surface, this makes the Sun appear to stop moving across the sky, reverse direction, and then resume its original path. For an observer at just the right location on Mercury, this creates the surreal experience of a double sunrise or double sunset. The Sun would peak above the horizon, climb partway into the sky, descend back below the horizon, and then rise again. This is yet another example of how orbital mechanics can create outcomes that seem impossible. Fact 15. Mercury has ice in permanent shadow. Here's a fact that seems contradictory at first. Mercury, the closest planet to the Sun, a world where daytime temperatures can reach 800 degrees Fahrenheit, has water ice. How is this possible? The answer lies in Mercury's unique geography and lack of atmosphere. Mercury has deep craters at its north and south poles, craters whose floors are in permanent shadow because Mercury has almost no axial tilt. The Sun never rises high enough to shine into the bottoms of these polar craters. Without sunlight to warm them and without an atmosphere to transport heat, these permanently shadowed regions remain incredibly cold. Cold enough for water ice to remain stable for billions of years. Scientists discovered this ice using radar observations and data from spacecraft orbiting Mercury. The ice likely came from comet impacts over Mercury's history. When comets, which are made largely of ice, crashed into Mercury, some of the ice was scattered across the surface. Most of it vaporized in the intense sunlight, but ice that landed in these permanently shadowed craters remained frozen. Some of the ice may even be covered by a layer of dark organic material, further insulating it from heat. This discovery shows us that water ice can exist even on the solar system's hottest worlds if conditions are just right. Fact 16. Venus spins backwards. Almost. Every planet in the solar system rotates in the same direction that the solar system formed, and the direction that the planets orbit the Sun. But Venus is different. Venus has what's called retrograde rotation, meaning it spins in the opposite direction from most other planets. On Earth, the sun rises in the east and sets in the west because of the direction we rotate. But on Venus, the sun rises in the west and sets in the east. Why does Venus spin backwards? Nobody knows for certain, but the most popular theory involves a massive collision early in Venus's history. Scientists believe that a large object, perhaps the size of a planet, might have struck Venus billions of years ago with enough force to dramatically change its rotation. Another theory suggests that Venus's thick atmosphere might have slowly altered its rotation over time through atmospheric tides. Whatever the cause, Venus now rotates so slowly and in the opposite direction that it takes 243 Earth days to complete one rotation. Combined with its orbital period of 225 Earth days, this creates a very unusual day-night cycle on Venus, where a day is actually longer than a year. Fact 17. A day on Venus is longer than its year. We've already mentioned this fact briefly, but it's so remarkable that it deserves its own explanation. Venus takes 243 Earth days to rotate once on its axis, but it only takes 225 Earth days to complete one orbit around the Sun. This means that a single day on Venus, from one sunrise to the next sunrise, is longer than a Venusian year. This strange situation results from Venus's extremely slow rotation combined with its relatively quick orbit around the Sun. If you were standing on Venus's surface and could see through the thick clouds to watch the Sun, you would experience incredibly long periods of daylight, followed by incredibly long nights. A day from sunrise to sunrise on Venus actually lasts 116 Earth days, which is shorter than the rotation period, because the orbital motion of Venus around the Sun affects when the Sun appears to rise. This creates a very unusual calendar on Venus, where seasons, years, and days don't align in any familiar way. It's another reminder that the rules we take for granted on Earth don't necessarily apply throughout the solar system. Fact 18. Venus's atmosphere creates crushing pressure. The atmosphere of Venus is not just thick, it's incredibly dense and massive. The surface pressure on Venus is 92 times greater than Earth's atmospheric pressure at sea level. To experience similar pressure on Earth, you would need to dive about 3,000 feet, or 900 meters, deep into the ocean. Imagine the weight of the entire ocean pressing down on you, and you'll get a sense of what the Venusian atmosphere feels like. This immense pressure would crush most spacecraft and equipment not specifically designed to withstand it. Several Soviet Venera landers managed to reach Venus's surface in the 1970s and 80s, but even these heavily armored probes only survived for a few hours before succumbing to the heat and pressure. The thick atmosphere also makes the environment at Venus's surface very strange. The atmospheric pressure is so high that carbon dioxide behaves more like a liquid than a gas. Wind moves very slowly at the surface because the atmosphere is so dense. Though high in the atmosphere, hurricane-force winds whip around the planet. This crushing pressure is yet another reason why Venus, despite being similar in size to Earth, is utterly inhospitable to life as we know it. Fact 19. It rains. Sulfuric acid on Venus. Venus's clouds aren't made of water vapor like Earth's clouds. They're made of sulfuric acid, high in Venus's atmosphere, at altitudes of about 45 to 70 kilometers above the surface. Thick clouds of sulfuric acid droplets encircle the planet. These clouds reflect so much sunlight that Venus is the brightest planet in Earth's sky, often visible even in daylight. But these beautiful clouds contain something deadly. The sulfuric acid forms when sulfur dioxide, released by volcanic activity on Venus's surface, combines with water vapor in the atmosphere. The result is concentrated sulfuric acid that's strong enough to dissolve metal. These acid droplets fall through the atmosphere as rain, creating downpours of corrosive liquid. However, here's the catch. The surface of Venus is so incredibly hot, around 870 degrees Fahrenheit, that the sulfuric acid raindrops evaporate long before they reach the ground. They fall from the clouds, descend through the thick atmosphere, and evaporate at altitudes of about 25 kilometers above the surface. So while it does rain sulfuric acid on Venus, this rain never reaches the surface. Instead, it evaporates and rises back up to form clouds again, creating a cycle of evaporation and condensation. This acid rain cycle is just one more way that Venus is a hostile world. Fact 20. Venus is Earth's twin, but totally different. Venus is often called Earth's twin or sister planet, and on paper, the comparison makes sense. Venus is almost exactly the same size as Earth, with a diameter of about 12,000 kilometers compared to Earth's 12,700 kilometers. Venus has about 80% of Earth's mass and similar internal composition with a rocky mantle surrounding an iron core. The gravity on Venus is about 90% of Earth's gravity, so you would feel almost the same weight. Both planets are rocky worlds in the inner solar system, and both have substantial atmospheres. But despite these similarities, Venus and Earth couldn't be more different in terms of environment and habitability. Venus's surface is hot enough to melt lead, with temperatures around 870 degrees Fahrenheit. The atmosphere is thick with carbon dioxide and sulfuric acid clouds. There's no liquid water on the surface. The crushing atmospheric pressure would kill you instantly. Venus represents what scientists call a runaway greenhouse effect, where positive feedback loops cause the planet to heat up out of control. Understanding why Venus turned out so differently from Earth despite their similar starting conditions is one of the key questions in planetary science. Fact 21. The Moon is slowly leaving Earth, and the Moon seem like permanent partners, locked together as they orbit the Sun. But this partnership is slowly changing. The Moon is drifting away from Earth at a rate of about 1.5 inches or 3.8 centimeters per year. This might not sound like much, but over millions and billions of years, this movement adds up significantly. The reason for the Moon's retreat involves tidal forces. The Moon's gravity creates tides in Earth's oceans, pulling water into bulges on the sides of Earth facing toward and away from the Moon. Earth's rotation carries these tidal bulges slightly ahead of the Moon, and the gravity of these bulges pulls on the Moon, transferring energy to it and gradually pushing it into a higher orbit. At the same time, this transfer of energy slows Earth's rotation, making our days longer. Billions of years ago, the Moon was much closer to Earth, and Earth's day was much shorter, perhaps only 5 or 6 hours long. The Moon was so close that it would have appeared enormous in the sky. As time goes on, the Moon will continue to move away, and Earth's rotation will continue to slow. Eventually, billions of years in the future, Earth's day and the Moon's orbital period will synchronize, and both will be about 47 current days long. Fact 22. Earth has multiple mini-moons. When someone asks how many moons Earth has, the answer is always one, right? Well, technically yes, but Earth actually has several small asteroids that temporarily orbit our planet before moving on. These are called quasi-satellites or mini-moons. At least 5 of these objects are known, and there are probably more we haven't discovered yet. These mini-moons aren't permanently captured by Earth's gravity. Instead, they follow orbits around the Sun that are very similar to Earth's orbit, and for periods of time, they appear to orbit Earth as they dance along with us around the Sun. These temporary companions are usually very small, just a few meters to a few tens of meters across. One example is an asteroid called 2006 RH120, which was temporarily captured by Earth's gravity in 2006, orbited us for about a year, and then escaped back into a solar orbit. Another example is asteroid 469219 Kamo'olawa, which has been following a quasi-satellite orbit around Earth for about a century and will continue to do so for a few more centuries. These mini-moons remind us that Earth's gravitational influence extends far beyond the Moon, and our planet regularly captures and releases small asteroids. Fact 23. A hidden ocean exists deep in Earth's mantle. We're used to thinking of Earth's oceans as the only significant water reservoirs on our planet, but deep underground, there's a vast amount of water locked in rocks. Scientists have discovered a huge reservoir of water trapped in a layer of magma deep within Earth's mantle. This isn't liquid water in the sense of underground lakes or rivers. Instead, water molecules are trapped within the crystal structure of minerals in the mantle, particularly in a mineral called ringwoodite. The amount of water stored in this deep reservoir is staggering. Estimates suggest there's about 3 times the volume of all Earth's surface oceans trapped in this layer, which sits between 400 and 600 kilometers beneath Earth's surface. This water plays an important role in Earth's geology, affecting the properties of rocks and influencing volcanic activity and plate tectonics. The discovery of this deep water reservoir changed our understanding of Earth's water cycle. Water at the surface can be carried down into the mantle at subduction zones, where one tectonic plate slides beneath another. This water can then be stored in minerals or released during volcanic eruptions. This hidden ocean is a reminder that Earth's interior is far more complex and dynamic than we often imagine. Fact 24. Earth is not a perfect sphere. If you look at pictures of Earth from space, it appears to be a perfect blue sphere, but appearances can be deceiving. Earth is actually what scientists call an oblate spheroid, meaning it's slightly squashed at the poles and bulges at the equator. The difference isn't enormous, but it's measurable. Earth's diameter at the equator is about 43 kilometers larger than its diameter measured from pole to pole. This bulge exists because Earth rotates. The rotation creates centrifugal force that pushes material outward at the equator, where the rotational speed is highest. At the poles, there's no rotational motion, so there's no outward force. The result is a planet that's slightly wider than it is tall. This oblateness affects many things, from satellite orbits to the precise measurement of Earth's gravitational field. It also means that the point on Earth's surface farthest from the center of the planet isn't Mount Everest, the highest mountain above sea level. Instead, it's the peak of Mount Chimborazo in Ecuador, which sits right on the equator where Earth's bulge is greatest. This slight departure from perfect sphericity is a direct result of Earth's rotation and reminds us that planets are dynamic objects shaped by their motion. Fact 25. Most of Earth's oceans remain unexplored. We have sent spacecraft to every planet in the solar system, landed rovers on Mars, and even sent probes to orbit distant comets. But right here on Earth, more than 80% of our oceans remain unmapped, unobserved, and unexplored. The deep ocean is one of the least understood environments on our planet. The ocean covers about 71% of Earth's surface and contains about 97% of Earth's water. Yet we've explored only a tiny fraction of this vast realm. The deep ocean is difficult to explore because of the crushing pressure, the complete darkness, and the sheer vastness of the area. Submersibles can only reach the deepest parts of the ocean for short periods, and mapping the seafloor requires expensive sonar equipment on ships. Despite these challenges, scientists have discovered incredible things in the parts of the ocean we have explored. Deep-sea hydrothermal vents teeming with unique life forms, underwater volcanoes, vast mountain ranges, and trenches deeper than Mount Everest is tall. There are almost certainly many more discoveries waiting in the unexplored regions of our oceans. It's humbling to realize that we know more about the surface of Mars than we do about the deepest parts of our own oceans. Fact 26. The moon has quakes. Two earthquakes are familiar to most people, caused by the movement of tectonic plates and the release of stress in Earth's crust. But the moon also experiences quakes called moonquakes. These moonquakes have several causes. Some are caused by the gravitational stress from Earth. As the moon orbits Earth, our planet's gravity pulls on the moon, flexing it slightly. This tidal stress can cause the moon's interior to shift and crack, creating moonquakes. Other moonquakes are caused by impacts from meteorites hitting the moon's surface. Still others come from the moon's interior, slowly cooling and contracting, causing the crust to crack. Moonquakes are generally much weaker than earthquakes, but they last much longer. On Earth, earthquakes typically last less than a minute because Earth's interior is warm and somewhat plastic, which dampens seismic waves. But the moon's interior is cold and rigid, so seismic waves can reverberate through the moon for hours. When Apollo astronauts placed seismometers on the moon's surface, they detected thousands of moonquakes over several years of operation. These moonquakes tell us about the moon's internal structure and confirm that even though the moon appears dead and unchanging, it's still geologically active in subtle ways. Fact 27. Footprints on the moon last for millions of years. One of the most iconic images from the Apollo missions is a photograph of an astronaut's bootprint in the lunar dust. That footprint, and all the others left by the 12 astronauts who walked on the moon, will likely remain visible for millions of years. On Earth, footprints quickly disappear because of wind, rain, and other erosional processes. But the moon has no atmosphere, which means no wind to blow dust around and no rain to wash away tracks. There's also no liquid water and no biological activity to disturb the surface. The only processes that erase features on the moon's surface are very slow, the gradual accumulation of micrometeorite impacts and the slow, movement of dust caused by thermal cycling as the surface heats during the lunar day and cools during the lunar night. These processes work so slowly that it will take millions of years to noticeably erode the Apollo footprints. The same is true for the tire tracks left by the lunar rovers, the flag shadows, and the various equipment left behind. All of these marks will remain as a testament to humanity's first steps on another world. This preservation of surface features also means that the Moon keeps a record of its history going back billions of years, with ancient impact craters remaining perfectly preserved. Fact 28. Earth's atmosphere extends beyond the Moon. When you look at diagrams of Earth's atmosphere, they typically show it as a thin blue shell surrounding our planet, extending maybe a few hundred kilometers above the surface, where it gradually fades into space. But Earth's atmosphere actually extends much farther than most people realize. A tenuous outer layer called the geocorona, composed mostly of hydrogen atoms, extends out to about 630,000 kilometers from Earth's surface. The Moon orbits Earth at an average distance of about 384,000 kilometers. This means the Moon actually orbits within Earth's outer atmosphere. The geocorona is incredibly thin, far more tenuous than any vacuum we can create on Earth, but it's still technically part of our atmosphere. This extended atmosphere was discovered by analyzing data from the SOHO spacecraft, which can detect the faint ultraviolet light emitted by hydrogen atoms. The hydrogen in the geocorona comes from water vapor in Earth's lower atmosphere that's broken apart by sunlight, allowing hydrogen atoms to escape to high altitudes. This discovery doesn't mean the Moon has an atmosphere of its own, but it does mean that Earth's influence extends farther into space than we thought. Fact 29. Earth has a second moon. In addition to the mini-moons we discussed earlier, Earth has a particularly interesting companion called Asteroid 469219 Kamo-Oalewa. This object is so gravitationally tied to Earth that some scientists call it a quasi-satellite or even a second moon, though it's not a true satellite like our moon. Kamo-Oalewa follows an orbit around the Sun that's very similar to Earth's, but its orbit is also influenced by Earth's gravity in such a way that from our perspective, it appears to orbit Earth. The asteroid is very small, probably only about 40 to 100 meters across, and it stays relatively close to Earth as both objects orbit the Sun. Kamo-Oalewa has been following this quasi-satellite orbit for about a century, and it will probably continue for several more centuries before eventually breaking free. What makes this asteroid particularly interesting is that scientists believe it might actually be a chunk of the Moon that was blasted off by an impact millions of years ago. Spectroscopic observations show that its composition is similar to lunar rocks. If this is true, Kamo-Oalewa represents a piece of the Moon that's been orbiting in space for millions of years, occasionally coming close to its parent body. Fact 30. The Moon has extreme cold spots. We've talked about how hot various places in the solar system can get, but what about cold? The coldest place we've measured in the solar system is actually on our own Moon, in permanently shadowed craters at the lunar poles. These craters are so deep and located at just the right angles that sunlight never reaches their floors. Without sunlight to warm them and without an atmosphere to transport heat, these shadowed regions become incredibly cold. Temperatures in these permanently shadowed craters can drop to minus 410 degrees Fahrenheit or minus 245 degrees Celsius. That's only about 30 degrees above absolute zero, the coldest possible temperature in the universe. These cold traps are so frigid that they can hold onto water ice and other volatile substances for billions of years. In fact, scientists have confirmed that these craters do contain water ice, making them potential resources for future lunar missions. The extreme cold in these craters is colder than Pluto's surface, colder than most places in the outer solar system. It seems strange that the coldest measured place in the solar system is on a world that's so close to the Sun, but it demonstrates how important sunlight is for heating surfaces. Without direct sunlight, even worlds close to the Sun can become freezing cold. These permanently shadowed regions are some of the most pristine and ancient environments in the solar system, preserving a record of cometary impacts and other processes that date back billions of years. Fact 31. Mars has the largest volcano in the solar system. When you think of large volcanoes, you might picture Mount Everest or perhaps Hawaii's Mauna Loa, the largest volcano on Earth. but these pale in comparison to Olympus Mons on Mars. Olympus Mons is the largest volcano in the entire solar system. This shield volcano is absolutely enormous, measuring about 620 kilometers across at its base, roughly the same size as the entire state of Arizona. It rises 25 kilometers above the surrounding plains, making it about 3 times taller than Mount Everest. The summit caldera alone is about 80 kilometers wide and 3 kilometers deep. What makes Olympus Mons even more remarkable is its shape. The volcano has such a gentle slope that if you were standing on its peak, you wouldn't be able to see the base because it would extend beyond the horizon. The curvature of Mars itself would hide the lower slopes from view. The volcano is so wide and has such a gradual incline that a person standing on it might not even realize they were on a mountain. Olympus Mons formed over billions of years as lava repeatedly erupted from the same spot. Unlike Earth, Mars doesn't have plate tectonics, so volcanic hotspots remain in the same place, allowing volcanoes to grow to enormous sizes. Fact 32. Mars has blue sunsets. Sunsets on Earth paint the sky in brilliant shades of red, orange, and pink. The colors result from the way Earth's atmosphere scatters sunlight. Short wavelength blue light scatters in all directions, making the sky blue during the day. At sunset, sunlight passes through more atmosphere, and the blue light is scattered away, leaving the longer wavelength red and orange light to color the sky. But on Mars, something different happens. Mars has blue sunsets. Images taken by Mars rovers show that as the sun sets on Mars, the area around the sun glows blue, while the rest of the sky takes on reddish and pink hues. This seems backwards compared to Earth, but it makes sense when you understand Mars's atmosphere. Mars has a very thin atmosphere composed mostly of carbon dioxide, and this atmosphere is filled with fine dust particles. These dust particles are just the right size to scatter red light efficiently, while allowing blue light to pass through more directly. During the day, the Martian sky appears reddish or butterscotch-colored because of this dust, but at sunset, the dust particles scatter the red light away from the setting sun, while blue light penetrates through the dust, creating a blue glow around the sun. This beautiful phenomenon is just one more example of how familiar processes can produce unexpected results on different worlds. Fact 33. Mars has planet-wide dust storms. Mars is a dusty world, and sometimes that dust takes over the entire planet. Mars experiences dust storms that can grow so large they engulf the entire planet for months at a time. These global dust storms are unique to Mars in our solar system. They typically occur when Mars is closest to the Sun in its elliptical orbit, a time when more solar energy reaches the surface. A local dust storm might start in one region when the surface heats up enough to create strong winds. These winds lift dust particles into the thin atmosphere, and the suspended dust absorbs more sunlight, heating the atmosphere and creating even stronger winds. This positive feedback loop can cause the storm to grow rapidly. Within weeks, a local storm can spread to cover the entire planet. During a global dust storm, the sky turns dark even during daytime. The dust blocks sunlight from reaching the surface, which can be dangerous for solar-powered equipment. In 2018, a global dust storm on Mars effectively ended the Opportunity rover's mission when the rover couldn't generate enough solar power to keep operating. These storms can last for months before the dust gradually settles back to the surface. Global dust storms are reminders of how dynamic planetary atmospheres can be. Fact 34. Mars's moons are probably captured. Asteroids. Mars has 2 small moons named Phobos and Deimos, which mean fear and panic in Greek. These moons are tiny compared to Earth's moon. Phobos is only about 22 kilometers across at its widest point, and Deimos is even smaller at only about 12 kilometers. Both moons are irregularly shaped, more like potatoes than spheres. Their small size and odd shapes suggest they didn't form alongside Mars the way our moon formed alongside Earth. Instead, scientists believe Phobos and Deimos are asteroids that were captured by Mars's gravity early in the planet's history. The moon's composition supports this theory. They appear to be made of dark, carbon-rich rock similar to certain types of asteroids found in the outer asteroid belt. Their orbits are also consistent with captured objects that have gradually settled into more circular paths around Mars over billions of years. How Mars managed to capture 2 asteroids is still debated. Perhaps the asteroids passed close to Mars when the planet still had a thicker atmosphere that could slow them down enough for gravity to capture them. Or maybe they were captured during a period when Mars had a more massive atmosphere created by intense volcanic activity. Whatever the mechanism, Phobos and Deimos represent captured wanderers now bound to Mars. Fact 35. Phobos is doomed. The story of Phobos. Mars's larger moon has a tragic ending written in orbital mechanics. Phobos is gradually spiraling inward toward Mars, getting about 2 centimeters closer to the planet every year. This happens because of tidal forces between Mars and Phobos. As Phobos orbits Mars, its gravity creates small tidal bulges in Mars's crust. These bulges lag slightly behind Phobos's position, and their gravity pulls back on the moon, slowing it down. When an orbiting object slows down, it falls into a lower orbit, bringing it closer to the planet. This process has been going on for millions of years, and it will continue until Phobos meets one of 2 fates. In about 50 million years, Phobos will either get close enough to Mars that the planet's tidal forces rip the moon apart, creating a ring of debris around Mars, or Phobos will hold together and crash into Mars's surface in a spectacular impact. Either way, Phobos is doomed. This might seem like a long time, but it's a blink of an eye in geological terms. Mars may one day have a ring system created from the remains of its moon, a reminder that the solar system continues to evolve and change. Fact 36. Mars has a canyon that could swallow America. The Grand Canyon in Arizona is an impressive geological feature, stretching about 446 kilometers long, up to 29 kilometers wide, and over 1.8 kilometers deep. But Mars has a canyon system that makes the Grand Canyon look tiny. Valles Marineris, the Valley of the Mariner, is a vast system of canyons on Mars that stretches over 4,000 kilometers long, reaches widths of 200 kilometers, and plunges up to 7 kilometers deep in places. The entire continental United States could fit inside this canyon system. Valles Marineris is so large that if you stood on one rim, you wouldn't be able to see the other side even on a clear day because it extends beyond the horizon. The canyon system formed differently from the Grand Canyon. While the Grand Canyon was carved by water erosion over millions of years, Valles Marineris appears to have formed primarily through tectonic processes. As Mars's crust stretched and cracked billions of years ago, huge sections of ground collapsed, creating this enormous rift valley. Some parts of the canyon may have been enlarged by water erosion, lava flows, and landslides, but the basic structure is tectonic. This massive scar across Mars's face is visible from Earth through telescopes and serves as a reminder of the violent geological processes that shaped Mars billions of years ago. Fact 37. Mars has seasons like Earth despite being a cold desert world. Mars experiences seasons much like Earth does. This happens because Mars has an axial tilt similar to Earth's. Earth is tilted about 23.5 degrees relative to its orbit, which creates our seasons as different hemispheres receive more or less direct sunlight throughout the year. Mars is tilted about 25 degrees, so it also has seasons. However, Martian seasons are about twice as long as Earth's seasons because Mars takes longer to orbit the Sun. A Martian year is about 687 Earth days long, so each Martian season lasts roughly 5 or 6 Earth months. During the Martian winter, the polar ice caps grow larger as carbon dioxide from the atmosphere freezes onto them. During summer, the ice caps shrink as the frozen carbon dioxide sublimes back into gas. The changing seasons affect Mars's atmosphere, weather patterns, and even the planet's atmospheric pressure. Mars rovers have observed these seasonal changes directly, watching the landscape transform as frost appears and disappears, and as dust storms come and go with the seasons. Understanding Mars's seasons is important for planning future missions, as different seasons present different challenges for landing, operation, and survival on the Martian surface. Fact 38. Mars once had rivers and oceans. When we look at Mars today, we see a cold, dry desert world with no liquid water on its surface. But abundant evidence suggests Mars was once a very different place. Images from orbit reveal features that look exactly like ancient river valleys, with branching tributaries and meandering channels carved into the Martian surface. There are also vast plains that appear to be ancient ocean basins, complete with what look like shorelines marking where water once lapped against land. Delta formations where rivers emptied into standing water can be seen in multiple locations. Rounded pebbles on Mars's surface indicate they were smoothed by flowing water. Minerals that only form in the presence of liquid water have been detected across Mars. All this evidence points to a warmer, wetter Mars billions of years ago, a planet with a thicker atmosphere, running water, lakes, and possibly even a northern ocean that covered about a third of the planet's surface. What happened to all that water? Some evaporated into space after Mars lost most of its atmosphere. Some froze and is now locked in the polar ice caps and underground ice deposits. The transformation of Mars from a potentially habitable world to the frozen desert we see today is one of the great mysteries of planetary science. Fact 39. A day on Mars feels almost like an Earth Day 1. Of the convenient coincidences for future Mars exploration is that a day on Mars feels very similar to a day on Earth. Mars rotates on its axis once every 24 hours and 37 minutes. This Martian day, called a sol, is only slightly longer than an Earth day. For astronauts on Mars, this similarity would make adjusting to the local day-night cycle relatively easy compared to other worlds where days might last weeks or months. Mission controllers for Mars rovers have to adjust their schedules to Mars time, slowly drifting out of sync with Earth days as they work according to Martian sols. Over time, this creates a shifting schedule where a mission controller might work during Earth's nighttime to operate a rover during Mars's daytime. Despite the inconvenience, the similarity between Earth and Mars days is fortunate. It means solar panels on Mars generate power on a predictable cycle similar to Earth, and the day-night temperature swings are spread over a familiar time frame. This makes Mars more accessible than it would be if its rotation were drastically different. This similarity is one of many reasons Mars is considered the most promising planet for future human exploration and potentially colonization. Fact 40. Mars has avalanches happening. Right now, Mars isn't a dead world frozen in time. Dynamic processes are happening there right now, including avalanches. Spacecraft orbiting Mars have captured images of avalanches in action, with clouds of ice and dust tumbling down steep cliffs. These avalanches typically occur at Mars's North Polar region in the spring, when seasonal warming causes the cliff faces to destabilize. The cliffs are made of layers of water ice, carbon dioxide ice, and dust that have accumulated over thousands of years. As spring arrives and temperatures rise, the frozen carbon dioxide begins to sublime, turning directly from solid to gas. This process weakens the cliff structure until chunks break free and cascade down the cliff face. The falling material creates clouds of dust and ice particles that billow outward, sometimes extending hundreds of meters from the cliff base. These avalanches can involve thousands of tons of material falling at once. The fact that we can observe these events happening in real time from orbit is remarkable. It shows us that Mars is still an active world where erosion, deposition, and landscape modification continue today. These observations also help scientists understand how Mars's climate and surface interact, knowledge that will be crucial for future human missions to the planet. Fact 41. Jupiter's Great Red Spot is an ancient storm. When you look at Jupiter through a telescope, the most prominent feature is a large reddish oval called the Great Red Spot. This isn't just a surface feature or geological formation, it's a storm. A gigantic anticyclonic storm that has been raging for at least 400 years, possibly much longer. The first confirmed observations of the Great Red Spot date back to the 1600s, and it may have been observed even earlier. This storm is enormous. At its largest, the Great Red Spot was big enough to fit 3 Earths side by side. Recently it has been shrinking, but it's still larger than Earth. The storm consists of winds reaching speeds of up to 430 kilometers per hour. Swirling around a high-pressure center. The red color comes from complex chemical reactions involving the storm clouds, though scientists are still debating the exact chemicals responsible. What keeps this storm going for centuries when storms on Earth dissipate in days or weeks? Jupiter has no solid surface to create friction that would slow the storm down. The storm also draws energy from Jupiter's internal heat and from the turbulent atmosphere around it. The Great Red Spot is a reminder that gas giant planets are extremely dynamic worlds with weather systems that dwarf anything on Earth. Fact 42. Jupiter protects the inner solar system. Jupiter isn't just the largest planet in our solar system, it also acts as a cosmic guardian for the inner planets, including Earth. Jupiter's immense gravity pulls in comets and asteroids that might otherwise collide with the inner planets. When a comet or asteroid's orbit brings it near Jupiter, the giant planet's gravity can capture it, fling it out of the solar system entirely, or pull it in for a collision with Jupiter itself. We've actually witnessed this protection in action. In 1994, Comet Shoemaker-Levy 9 broke apart and crashed into Jupiter in a series of spectacular impacts. Each impact released energy equivalent to millions of nuclear bombs, creating temporary dark spots on Jupiter's surface larger than Earth. Without Jupiter, some of those impacts might have been headed toward the inner solar system instead. Computer simulations suggest that without Jupiter's gravitational influence, Earth would be struck by large asteroids and comets much more frequently, possibly preventing complex life from ever developing. However, Jupiter's protection isn't perfect. Sometimes Jupiter's gravity can actually redirect objects toward the inner solar system. But overall, Jupiter acts more as a shield than a threat, making the inner solar system a safer place for life to evolve. Fact 43. Jupiter is not a failed star. There's a common misconception that Jupiter is a failed star, a ball of gas that almost had enough mass to ignite nuclear fusion, but fell short. This isn't really accurate. While Jupiter is indeed made mostly of hydrogen and helium like a star, it's nowhere near massive enough to become a star. For nuclear fusion to begin in a star's core, the core must reach temperatures of about 10 million degrees Celsius. This requires an enormous amount of mass pressing down from above, compressing and heating the core. Jupiter would need to be about 80 times more massive than it currently is before it could ignite fusion and become a brown dwarf, the smallest type of star. Jupiter has only about 1,000th the mass of the Sun. To become a true star like the Sun, Jupiter would need to be about 1,000 times more massive. So Jupiter isn't a failed star, it's a highly successful planet, the largest in our solar system. That said, Jupiter does generate its own heat through gravitational contraction. As the planet slowly shrinks, gravitational potential energy converts to heat, making Jupiter radiate about 1.6 times as much heat as it receives from the Sun. This internal heat drives Jupiter's powerful weather systems and contributes to the planet's dynamic atmosphere. Fact 44. Jupiter has permanent auroras. Earth's auroras, the northern and southern lights, are beautiful displays of colored light that appear when charged particles from the Sun interact with Earth's magnetic field and atmosphere. Jupiter also has auroras, but Jupiter's auroras are on an entirely different scale. They are hundreds of times more energetic than Earth's auroras. And unlike Earth's auroras, which come and go with solar activity, Jupiter's auroras are permanent features at both poles. Jupiter has the strongest magnetic field of any planet in the solar system, about 20,000 times stronger than Earth's field. This powerful magnetism captures charged particles from the solar wind and from Jupiter's volcanic moon, Io, which constantly spews ions into space. These particles spiral along Jupiter's magnetic field lines toward the poles, where they slam into the upper atmosphere and create brilliant auroras. Jupiter's auroras emit tremendous amounts of energy, including X-rays that can be detected by space telescopes. The auroral ovals at Jupiter's poles are enormous, larger than Earth itself. The auroras are constantly active, pulsing and flickering as they respond to changes in Jupiter's magnetosphere. Studying Jupiter's auroras helps scientists understand magnetic fields and plasma physics in ways that wouldn't be possible by studying Earth alone. Fact 45. Io is the most volcanic world. Jupiter has over 90 known moons, and one of them holds a remarkable record. Io, the innermost of Jupiter's 4 large Galilean moons, is the most volcanically active body in the entire solar system. Io has over 400 active volcanoes, and at any given time, dozens of them are erupting. These aren't small volcanic vents either. Some of Io's volcanoes shoot plumes of material hundreds of miles high, far above the surface. The plumes are so powerful they can be seen from spacecraft flying past Jupiter. The lava on Io can reach temperatures exceeding 1,700 degrees Celsius, hot enough to melt rock and create glowing lava lakes and rivers. What powers all this volcanic activity? Io orbits very close to Jupiter, and the giant planet's gravity creates enormous tidal forces that flex Io's interior. At the same time, Io's orbit is perturbed by Jupiter's other large moons, Europa and Ganymede, which prevent Io's orbit from becoming perfectly circular. This combination of tidal forces constantly squeezes and stretches Io, generating tremendous friction and heat inside the moon. The heat melts rock, creating magma that erupts through the surface. Io is constantly turning itself inside out, with volcanic activity resurfacing the moon so quickly that there are no impact craters visible. The entire surface is geologically young, perhaps only a few million years old. Fact 46. Jupiter spins incredibly fast. Despite being by far the largest planet in the solar system, Jupiter rotates faster than any other planet. Jupiter completes one full rotation in just under 10 hours. This rapid rotation has dramatic effects on the planet. The fast spin creates powerful forces that stretch Jupiter's equator outward, making the planet noticeably flattened at the poles and bulging at the equator. Jupiter's equatorial diameter is about 9,000 kilometers larger than its polar diameter, a dramatic example of oblateness. The rapid rotation also drives Jupiter's powerful jet streams and creates the distinctive banded appearance we see in the atmosphere. Light-colored zones and dark-colored belts circle the planet parallel to the equator, created by rising and falling gas in Jupiter's atmosphere combined with the planet's rapid rotation. These bands move at different speeds relative to each other, creating turbulence where they meet. This turbulence spawns the storms and swirling features we observe, including the Great Red Spot. The fast rotation also affects Jupiter's magnetic field, helping to power the strongest planetary magnetosphere in the solar system. For a planet so massive, a 10-hour day seems impossibly short, but it's a testament to the angular momentum Jupiter has retained from the early solar system. Fact 47. You would never hit a surface falling into Jupiter if you somehow fell toward Jupiter and could survive the extreme conditions. An interesting question arises. What would you experience? You might expect to eventually hit a solid surface or at least encounter liquid, but that's not what would happen. Jupiter has no solid surface at all. It's a gas giant, meaning it's essentially a ball of hydrogen and helium gas surrounding a possible rocky core. As you fell deeper into Jupiter, the gas around you would gradually become denser and hotter. The pressure would increase steadily. Eventually, the pressure would become so great that the hydrogen gas would transition to a liquid state, but you wouldn't notice a distinct boundary. The transition from gas to liquid would be gradual. Falling deeper still, the pressure would become so intense that the liquid hydrogen would transform into an exotic state called metallic hydrogen, where hydrogen behaves like a liquid metal and can conduct electricity. Throughout all of this, there would be no surface to hit. You would just descend through increasingly dense and hot material until the pressure and temperature crushed and vaporized you. If Jupiter has a rocky core at its center, you would never reach it. You'd be destroyed long before getting that deep. This lack of a surface is a defining characteristic of gas giants, and a reminder that planets can exist in forms very different from rocky worlds like Earth. Fact 48. Jupiter has rings. Most people know about Saturn's spectacular ring system, but fewer people know that Jupiter also has rings. Jupiter's rings are much fainter and harder to see than Saturn's bright, icy rings. They were discovered by the Voyager 1 spacecraft in 1979, when the probe flew past Jupiter and looked back toward the Sun, seeing the rings backlit and shining faintly. Jupiter's ring system consists of 4 main components: a thick inner torus of particles called the halo ring, a relatively bright main ring, and 2 wide, faint gossamer rings. These rings are made primarily of dust-sized particles, rather than the chunks of ice that make up Saturn's rings. The particles come from Jupiter's small inner moons. When meteorites strike these moons, they blast dust into space, and this dust gets captured into orbit around Jupiter, forming the rings. The rings are constantly being replenished because the dust particles gradually spiral inward toward Jupiter, or get pushed outward by radiation pressure and the solar wind. Without constant replenishment from impacts on Jupiter's moons, the rings would disappear in a relatively short time. Jupiter's faint rings remind us that ring systems are more common than we once thought, with all 4 giant planets having some form of rings. Fact 49. It rains helium and neon on Jupiter. Jupiter's interior is a realm of extreme pressure and temperature where familiar materials behave in unfamiliar ways. Deep inside Jupiter, the pressure is so immense that helium and neon can no longer remain mixed with hydrogen. Instead, these elements separate out and form droplets, much like water vapor condenses into rain droplets in Earth's atmosphere. These droplets of helium and neon literally rain downward through Jupiter's interior, falling toward the core. This process releases gravitational energy as the heavy droplets sink through the lighter hydrogen, contributing to Jupiter's internal heat. The helium rain also explains a mystery scientists noticed about Jupiter's atmosphere. Jupiter has less helium in its outer atmosphere than expected, based on the planet's overall composition. Where did the helium go? It sank deep into the planet's interior as part of this rain process. This exotic precipitation happens because Jupiter's interior pressure reaches millions of times Earth's atmospheric pressure, creating conditions that don't exist anywhere on Earth. The concept of helium and neon rain is almost impossible to visualize because we have no everyday experience with materials behaving this way. But it's a real phenomenon, predicted by physics and supported by observations of Jupiter's composition. Fact 50. Jupiter's magnetic field is gigantic. We've mentioned Jupiter's powerful magnetic field already, but the sheer scale of this magnetosphere is worth emphasizing. Jupiter's magnetosphere is the largest structure in the solar system. If it were visible to the naked eye from Earth, it would appear larger than the full moon in our sky, despite being hundreds of millions of miles away. The magnetosphere extends millions of miles out from Jupiter, creating a vast region where Jupiter's magnetic field dominates over the solar wind. The magnetosphere is so large that it can take particles from the solar wind up to 2 hours to cross from one side to the other, traveling at over 1 million kilometers per hour. This enormous magnetic field is generated by electric currents flowing through the metallic hydrogen deep inside Jupiter. The magnetosphere is filled with trapped charged particles that form radiation belts far more intense than Earth's Van Allen belts. Any spacecraft passing through Jupiter's magnetosphere must be heavily shielded to survive the radiation. The magnetosphere also captures particles from Io's volcanoes, creating a torus of ionized gas that orbits Jupiter at Io's distance. Jupiter's magnetosphere is a cosmic laboratory where scientists can study plasma physics and magnetic phenomena on scales impossible to recreate on Earth. Fact 51. Saturn could float in water. Here's a thought experiment that captures just how unusual Saturn is. If you could find a bathtub large enough to hold Saturn, the entire planet would float. Saturn has an average density of only 0.69 grams per cubic centimeter, which is less than the density of water at 1 gram per cubic centimeter. This makes Saturn the only planet in the solar system that's less dense than water. How can a planet be less dense than water? Saturn is composed mostly of hydrogen and helium, the two lightest elements. These gases are compressed by Saturn's gravity, but even compressed, they remain less dense than water on average. Saturn does have a denser rocky core surrounded by layers of metallic hydrogen and liquid hydrogen, but the overall average density is still remarkably low. Of course, this is just a thought experiment. You couldn't actually place Saturn in water because the planet is massive and would gravitationally attract any water toward it. But the principle remains valid. Saturn's low density is one of its most distinctive characteristics and results from its composition as a gas giant made primarily of the lightest elements in the universe. This low density also affects Saturn's shape, as the rapid rotation can more easily deform the less dense material. Fact 52. Saturn's rings are surprisingly young. Saturn's rings are perhaps the most iconic feature in the solar system. They're visible through even small telescopes and make Saturn instantly recognizable. You might assume these magnificent rings have existed since Saturn formed billions of years ago, but you'd be wrong. Saturn's rings are surprisingly young, possibly forming only 100 to 200 million years ago. That might sound old, but it's recent in astronomical terms. Dinosaurs were roaming Earth when Saturn's rings formed. How do we know the rings are young? Several lines of evidence point to this conclusion. The rings are extremely bright and icy, which suggests they haven't been darkened by micrometeorite impacts and cosmic dust over billions of years. The rings also appear to be losing mass relatively quickly as material spirals inward towards Saturn, suggesting they won't last forever. If the rings were billions of years old, they should have either darkened or disappeared by now. Where did the rings come from? Scientists believe a moon or large comet probably ventured too close to Saturn and was torn apart by tidal forces. The debris spread out into a disk and formed the rings we see today. This means we're living at a special time in history when Saturn has these spectacular rings. They may not last more than another few hundred million years. Fact 53. Saturn's rings are made of water, ice. Despite spanning hundreds of thousands of kilometers across space, Saturn's rings are made of something familiar, water ice. The ring particles range in size from tiny grains smaller than a grain of sand to huge chunks the size of houses or even mountains. But most of the mass in the rings consists of water ice, with only traces of rocky dust mixed in. The ice is remarkably pure and reflects sunlight very efficiently, which is why the rings are so bright and visible. Where did all this ice come from? If the rings formed from a destroyed moon or comet, that object must have been made primarily of ice. Many of Saturn's moons are ice-rich worlds, and comets are essentially dirty snowballs, so an icy origin for the rings makes sense. The composition of the rings tells us about conditions in the outer solar system where ice is stable. In the warmer inner solar system near Earth, exposed water ice would quickly sublimate into space. But out at Saturn's distance, temperatures are cold enough that water ice remains solid indefinitely. Studying Saturn's rings helps scientists understand icy bodies throughout the solar system and provides clues about how planetary systems form and evolve. Fact 54. Saturn's rings aren't solid. When you see pictures of Saturn's rings, they might look like solid structures, perhaps a disk of material you could walk on, but that's an illusion. Saturn's rings aren't solid at all. They're made of countless individual particles, each in its own orbit around Saturn. The particles range from microscopic dust grains to chunks the size of buildings. Each particle orbits Saturn independently, following the laws of orbital mechanics. Particles closer to Saturn orbit faster than those farther away. The rings appear solid from a distance because there are trillions upon trillions of particles, and they're arranged in a relatively flat disk. If you could fly a spacecraft through the rings, you would encounter particle after particle, but there would be plenty of empty space between them. In fact, NASA's Cassini spacecraft deliberately flew through gaps in the rings multiple times and survived. The particles collide with each other occasionally, which helps keep the rings flat and prevents them from spreading out vertically. These collisions also generate subtle waves and structures in the rings. The rings are divided into multiple sections with gaps between them, created by gravitational interactions with Saturn's moons. This structure of countless independent particles creates one of the most beautiful sights in the solar system. Fact 55. Saturn has a hexagonal storm at its north pole. Saturn is full of surprises, but one of the strangest features is at the planet's north pole. There's a persistent hexagonal-shaped jet stream, a six-sided geometric pattern that has mystified scientists since its discovery by the Voyager spacecraft in the 1980s. The hexagon is enormous, with each side measuring about 9,000 kilometers long, wider than Earth's diameter. The jet stream that forms the hexagon has winds reaching speeds of about 320 kilometers per hour. Inside the hexagon is a massive rotating storm similar to a hurricane. What creates this bizarre geometric shape? Scientists believe it forms from the interaction between different jet streams at different latitudes. When jet streams with different speeds interact, they can form wave patterns. On Saturn, the particular speeds and configurations of these jet streams create a standing wave pattern with 6 sides. Laboratory experiments recreating similar fluid flows have produced hexagonal patterns, supporting this explanation. The hexagon has persisted for decades, remaining stable even as Saturn's seasons change. There's nothing else quite like it in the solar system, a perfect reminder that nature can create geometric patterns that look almost artificial, but arise from natural physical processes. Fact 56. Titan has a thicker atmosphere than Earth. Saturn's largest moon, Titan, is an extraordinary world. It's the only moon in the solar system with a substantial atmosphere, and that atmosphere is even thicker than Earth's. The atmospheric pressure at Titan's surface is about 1.5 times Earth's surface pressure. This thick atmosphere is composed mostly of nitrogen, like Earth's atmosphere, but with significant amounts of methane and other organic compounds. Titan's atmosphere extends hundreds of kilometers above the surface, creating a thick haze that obscures our view of the surface. The atmosphere is so thick and the gravity is so low that the air pressure and density are quite comfortable by human standards. Titan is also the only other body in the solar system besides Earth with stable liquid on its surface. But this isn't water. On Titan's frigid surface, where temperatures average minus 180 degrees Celsius, water is frozen as hard as rock. Instead, Titan has rivers, lakes, and seas of liquid methane and ethane. These hydrocarbons exist as liquids at Titan's temperatures, and they evaporate, form clouds, rain down, flow in rivers, and collect in lakes, creating a complete hydrological cycle similar to Earth's water cycle. Titan is a truly alien world that nevertheless has many Earth-like features, making it fascinating for study. Fact 57. you could fly on Titan with wings. Here's one of the most delightful facts about any world in the solar system. On Titan, a human could theoretically strap wings to their arms and fly. Titan has a unique combination of physical properties that make human-powered flight possible. The atmosphere is thick, providing plenty of air for wings to push against. But the gravity is low, only about 14% of Earth's gravity. The combination of dense air and low gravity means that wings would generate plenty of lift, while you would weigh very little. Calculations show that with wings attached to your arms, you could generate enough lift by flapping to achieve flight. You'd need a pressurized suit to survive Titan's frigid temperatures and to breathe, and the wings would need to be a few meters across to provide enough area. But with those provisions, you could fly around Titan like a bird, powered only by your muscles. This is impossible on any other moon or planet. Earth's gravity is too strong, and Mars's atmosphere is too thin. Only Titan has just the right combination of properties. Imagine exploring Titan by flying over its methane lakes and landing on its ice mountains. Of all the fascinating facts about the solar system, this might be one that most captures the imagination. Fact 58. Enceladus has an ocean beneath its ice. Saturn has another remarkable moon called Enceladus. This small moon, only about 500 kilometers in diameter, harbors one of the most exciting discoveries in recent planetary science. Enceladus has a global ocean of liquid water beneath its icy crust. We know this ocean exists because Enceladus shoots enormous geysers of water ice and vapor into space from cracks at its south pole. NASA's Cassini spacecraft flew through these geysers multiple times, analyzing the composition of the material. The geysers contain water ice, salt, silica, and organic molecules, indicating they come from a salty liquid water ocean that's in contact with a rocky seafloor. The ocean is kept liquid by tidal heating, the same process that creates volcanic activity on Io. Saturn's gravity flexes Enceladus as the moon orbits, generating heat through friction in the moon's interior. This heat is enough to maintain a liquid ocean despite the frigid temperatures of the outer solar system. The presence of liquid water in contact with rock and organic molecules makes Enceladus one of the best places to search for life beyond Earth. The geysers continuously spray water into space, where some of it freezes and falls back to Enceladus, resurfacing the moon and making it one of the brightest objects in the solar system. The rest of the water escapes and forms one of Saturn's faint outer rings. The discovery of Enceladus's ocean transformed our understanding of where life might exist in the solar system, suggesting that even small, distant moons can harbor potentially habitable environments. Fact 59. Iapetus looks like a cosmic yin-yang. Symbol Saturn has over 80 known moons, and one of the strangest is Iapetus. This moon has a bizarre two-tone appearance that makes it look almost like someone painted one half black and left the other half bright white. One hemisphere of Iapetus is as dark as coal, reflecting only about 4% of the sunlight that hits it, making it one of the darkest surfaces in the solar system. The other hemisphere is as bright as snow, reflecting about 60% of sunlight. The boundary between the dark and bright regions is relatively sharp, creating a striking appearance that reminded early observers of a yin-yang symbol. What causes this extreme difference? Scientists believe the dark material comes from outside Iapetus. As the moon orbits Saturn, its leading hemisphere sweeps up dark dust particles that probably come from other moons farther out. Once this dark material lands on Iapetus, it absorbs sunlight and warms up. The warming causes ice to sublimate from the dark regions, and this ice moves through space and settles on the cold, bright regions, making them even brighter. This positive feedback loop has created the stark contrast we see today. Iapetus also has another unusual feature, a massive ridge that runs almost exactly along its equator, giving the moon a walnut-like appearance. The origin of this ridge remains mysterious. Fact 60. Mimas looks like the Death Star, one of Saturn's smaller moons. Mimas bears an uncanny resemblance to the Death Star space station from the Star Wars films. This resemblance is purely coincidental, but remarkable nonetheless. Mimas has a giant impact crater called Herschel crater that dominates one hemisphere of the moon. The crater is about 130 kilometers across, roughly 1/3 the diameter of Mimas itself. The impact that created this crater must have nearly destroyed the entire moon. In the center of the crater is a prominent central peak about 6 kilometers high. When viewed from certain angles, this crater looks remarkably similar to the superlaser dish on the fictional Death Star. The resemblance is so striking that Mimas has become known as the Death Star moon in popular culture. What makes this coincidence even more interesting is that Mimas was photographed in detail by Voyager 1 in 1980, a few years after the first Star Wars film was released. The filmmakers couldn't have known what Mimas looked like when they designed the Death Star, yet nature created something that looks remarkably similar. Mimas is a reminder that sometimes reality can be as strange as fiction, and that the universe has a sense of humor. Beyond its Death Star appearance, Mimas is also the smallest known astronomical body that's rounded by its own gravity. Fact 61. Uranus rolls around the Sun. Most planets spin like tops, rotating around an axis that's roughly perpendicular to their orbital plane. But Uranus is different. Uranus is tilted on its side, rotating at a 98-degree angle relative to its orbit. This means Uranus essentially rolls around the Sun like a ball rolling along the ground. This extreme tilt has dramatic effects on the planet's seasons. As Uranus orbits the Sun, each pole alternately points toward or away from the Sun. When a pole points toward the Sun, that hemisphere experiences continuous daylight for 42 years. Meanwhile, the other hemisphere experiences continuous darkness for the same period. Then, as Uranus continues its orbit, the seasons reverse, and the previously dark hemisphere gets 42 years of continuous sunlight. What caused this bizarre tilt? Most scientists believe Uranus was knocked on its side by a massive collision early in the solar system's history. Perhaps a planet-sized object struck Uranus with enough force to tip it over. Computer simulations suggest this impact hypothesis is plausible. Another possibility is that multiple smaller impacts gradually tilted Uranus over time. Whatever the cause, Uranus's extreme tilt makes it unique among the planets and creates the strangest seasons in the solar system. Fact 62. Neptune was discovered with Mathor. The planets known to ancient astronomers were discovered by direct observation. People could see Mercury, Venus, Mars, Jupiter, and Saturn with their naked eyes. Uranus was discovered with a telescope in 1781, but Neptune was different. Neptune was the first planet discovered through mathematical prediction, rather than deliberate searching. After Uranus was discovered, astronomers carefully tracked its orbit. As decades passed, they noticed that Uranus wasn't moving exactly where Newton's laws of gravity predicted it should be. Something was pulling on Uranus, causing perturbations in its orbit. Two mathematicians, Urbain Le Verrier in France and John Couch Adams in England, independently analyzed these perturbations and calculated where an unknown planet would need to be to cause them. Le Verrier sent his predictions to astronomer Johann Galle in Germany, who pointed his telescope at the predicted location in September 1846. There, within a degree of the predicted position, was Neptune. This discovery was a triumph of mathematical physics and demonstrated that Newton's laws of gravity could predict astronomical phenomena with incredible precision. It showed that science could reveal hidden aspects of the universe through calculation and theory. Neptune remained the most distant known planet until Pluto's discovery in 1930, and it reclaimed that title when Pluto was reclassified as a dwarf planet in 2006. Fact 63. Neptune radiates. Its own heat Neptune receives very little energy from the Sun. At its distance of about 4.5 billion kilometers from the Sun, sunlight is almost 1,000 times weaker than it is at Earth. You might expect Neptune to be a frozen, inactive world, with barely any weather or atmospheric activity. But Neptune is surprisingly dynamic, with powerful storms and the fastest winds in the solar system. What powers all this activity? Neptune radiates more than twice as much heat as it receives from the Sun. The planet has a powerful internal heat source that's still not fully understood. Some of this heat comes from gravitational contraction as the planet slowly shrinks and converts gravitational potential energy into heat, similar to Jupiter. But Neptune's internal heat output is higher than can be explained by contraction alone. Some scientists think additional heat might come from chemical processes in Neptune's interior, possibly related to the precipitation of materials like diamonds in the mantle. Others suggest the heat might be left over from Neptune's formation billions of years ago. Whatever the source, this internal heat drives Neptune's weather systems and makes the planet far more active than it would be from solar heating alone. Neptune reminds us that planetary interiors can remain hot and active for billions of years. Fact 64. Uranus smells like rotten eggs. Here's a fact that's both amusing and scientifically interesting. If you could somehow survive in Uranus's upper atmosphere and take a whiff, you would smell rotten eggs. Uranus's upper atmosphere contains hydrogen sulfide, the same gas that gives rotten eggs their distinctive and unpleasant odor. Scientists discovered this by analyzing the composition of sunlight reflected from Uranus using spectroscopy. Most of the other giant planets have atmospheres dominated by ammonia and methane, but Uranus and Neptune have significant amounts of hydrogen sulfide in their upper clouds. This difference in atmospheric composition is one of the reasons scientists classify Uranus and Neptune as ice giants rather than gas giants like Jupiter and Saturn. The term ice giant doesn't mean these planets are made of solid ice. Instead, it refers to the fact that they contain large amounts of materials that astronomers call ices, which include water, ammonia, and methane. These ices exist as hot, dense fluids deep in the planet's interiors. The presence of hydrogen sulfide in Uranus's atmosphere provides clues about the conditions in the solar nebula when these planets formed and helps scientists understand the differences between the ice giants and gas giants. Fact 65. Neptune has the solar system's strongest winds. Neptune might be a cold, distant world, but its atmosphere is incredibly dynamic. Neptune has the fastest winds ever detected in the solar system, with speeds reaching up to 1,200 miles per hour, or about 2,000 kilometers per hour. That's more than 1.5 times the speed of sound in Earth's atmosphere. These supersonic winds blow westward in the opposite direction of Neptune's rotation. The winds create massive storm systems, including features that have been observed and tracked by telescopes and spacecraft. In 1989, when Voyager 2 flew past Neptune, it observed a massive storm system called the Great Dark Spot, similar to Jupiter's Great Red Spot, but much more transient. By the time the Hubble Space Telescope observed Neptune a few years later, the Great Dark Spot had disappeared, but new storms had formed. What drives these incredible wind speeds? The answer lies partly in Neptune's internal heat. The heat rising from the interior creates powerful convection in the atmosphere, and the planet's rotation shapes these convection currents into high-speed jet streams. The weakness of the sun's heating at Neptune's distance also plays a role. On Earth, solar heating creates temperature differences that drive winds. On Neptune, the internal heat is more important, and the atmosphere may be freer to develop extreme wind patterns without being constrained by solar heating patterns. Fact 66. Uranus has rings. Two Saturn's rings are famous, and we've mentioned that Jupiter and Neptune also have ring systems. Uranus completes the set. All 4 giant planets have rings, though Uranus's rings are very different from Saturn's bright, icy rings. Uranus has 13 known rings, and they're dark, narrow, and faint. The rings are so dark that they reflect only about 2% of the light that hits them, making them very difficult to see. Unlike Saturn's rings, which are made primarily of bright water ice, Uranus's rings appear to be made of darker material, possibly organic compounds that have been darkened by radiation over time. The rings are also very narrow, typically only a few kilometers wide, though they orbit at distances of tens of thousands of kilometers from the planet. What keeps these narrow rings from spreading out? The answer is shepherd moons, small moons whose gravity constrains the ring particles. Uranus's rings were discovered in 1977 when astronomers watched Uranus pass in front of a distant star. Before and after Uranus blocked the star briefly dimmed several times, indicating something was blocking its light. Those brief dimmings were caused by Uranus's rings passing in front of the star. This discovery was later confirmed by Voyager 2 when it flew past Uranus in 1986. Fact 67. Triton orbits Neptune backwards. Neptune's largest moon, Triton, is unusual in many ways. One of the most significant is its orbit. Triton has a retrograde orbit, meaning it orbits Neptune in the opposite direction from the planet's rotation. This is extremely unusual for a large moon. Almost all large moons in the solar system orbit in the same direction their planet rotates because they formed from the same disk of material as the planet. Retrograde orbits are typically seen only in small captured objects or very distant irregular moons. Triton's retrograde orbit is strong evidence that Triton didn't form alongside Neptune but was captured by the planet's gravity. Scientists believe Triton originated in the Kuiper Belt, the region of icy objects beyond Neptune's orbit. Early in the solar system's history, Triton may have been part of a binary system, 2 objects orbiting each other. When this binary pair encountered Neptune, One object was flung away while Triton was captured. The capture process would have put Triton into an elliptical orbit that gradually became more circular over time due to tidal interactions. Today, Triton is in a nearly circular orbit, but that orbit is slowly decaying. Eventually, millions of years in the future, Triton will either crash into Neptune or be torn apart by tidal forces, possibly forming a spectacular ring system around the planet. Fact 68. Triton has cryovolcanoes. Triton isn't just unusual because of its backward orbit. It's also one of the most geologically active bodies in the solar system. When Voyager 2 flew past Triton in 1989, it discovered active cryovolcanoes on the Moon's surface. These aren't volcanoes that erupt molten rock. Instead, they erupt materials like liquid nitrogen, water, ammonia, and methane. On Triton's frigid surface, where temperatures hover around -235 degrees Celsius, these materials can behave like lava does on Earth. Voyager 2 actually observed eruption plumes shooting nitrogen gas and dark organic particles up to 8 kilometers above Triton's surface. These plumes were carried downwind by thin atmospheric winds and created dark streaks across Triton's icy surface. The energy for this activity might come from several sources. Tidal heating from Neptune could warm Triton's interior. Seasonal heating from the sun, even though it's very weak at Neptune's distance, might be enough to vaporize nitrogen ice and create eruptions. Triton's surface shows evidence of extensive resurfacing, with relatively few impact craters visible, suggesting the surface is geologically young. The combination of active geology, a thin nitrogen atmosphere, and its captured origin makes Triton one of the most fascinating moons in the solar system. Fact 69. Ice giants aren't made of solid ice. Despite their name, the ice giants Uranus and Neptune aren't made of solid ice, and you couldn't skate on them. The term ice giant refers to their composition, not their physical state. These planets contain large amounts of what astronomers call ices, which include water, ammonia, and methane. But deep inside Uranus and Neptune, temperatures and pressures are so extreme that these materials exist as hot, dense, slushy fluids, not as solid ice. Uranus and Neptune each have a relatively small rocky core, probably similar in composition to Earth, but more massive. Surrounding the core is a thick mantle of these hot, compressed ices mixed with hydrogen and helium. This mantle isn't solid and isn't liquid in the normal sense. It's a supercritical fluid, a state of matter where the distinction between liquid and gas breaks down. Above the mantle is an atmosphere of hydrogen, helium, and methane gas. The blue color of both planets comes from methane in their atmospheres, which absorbs red light and reflects blue light. The interior temperatures in these ice mantles can reach thousands of degrees Celsius, hot enough to melt rock. So ice giants are anything but icy in terms of temperature. The name refers to their composition and distinguishes them from gas giants like Jupiter and Saturn, which are made primarily of hydrogen and helium. Fact 70. Neptune took 165 years for one orbit. Neptune has an orbital period of about 165 Earth years. That means it takes 165 years for Neptune to complete one trip around the Sun. Neptune was discovered on September 23, 1846. It didn't complete its first observed orbit until July 11, 2011. Think about that. In all of human history before 2011, Neptune had never completed a full orbit since we knew it existed. Everyone who observed Neptune before 2011 saw it at only partial points in its orbit. Now we've observed more than one complete Neptune year, but just barely. This incredibly long orbital period reminds us how vast the solar system is. Neptune is so far from the Sun that its orbital path is about 28 billion kilometers long. Even moving at about 5.4 kilometers per second, Neptune takes 165 years to complete this journey. If you were born on Neptune, you would never live to see your first birthday unless you lived to be 165 Earth years old. Seasonal changes on Neptune take place over decades. Summer at Neptune's North Pole lasts about 40 years of Earth time. Understanding Neptune's long-term behavior requires observations spanning generations of human astronomers. Fact 71. Ganymede is larger than Mercury. When you think of large objects in the solar system, you probably think of planets. But one of Jupiter's moons is actually larger than a planet. Ganymede, the largest of Jupiter's moons, has a diameter of 5,268 kilometers. Mercury, the smallest planet in the solar system, has a diameter of 4,880 kilometers. That makes Ganymede about 10% larger in diameter than Mercury. Ganymede is also the largest moon in the entire solar system, bigger than Earth's moon, bigger than all of Saturn's moons, and bigger than every other moon orbiting any planet. Despite being larger than Mercury, Ganymede has only about half the mass. This is because Ganymede is made largely of water ice and rock, while Mercury is made mostly of iron and rock, which are much denser materials. Ganymede is substantial enough that it has its own magnetic field, the only moon known to have one. This magnetic field is generated by a liquid iron core deep inside the moon, similar to how Earth's magnetic field is generated. Ganymede also has a thin oxygen atmosphere created by charged particles breaking apart water ice on the surface. The moon likely has a subsurface ocean of liquid water sandwiched between layers of ice, making it another potential location for life in the solar system. Fact 72. Europa's ocean contains more water than Earth, Jupiter's moon. Europa is slightly smaller than Earth's moon, but it might contain more water than all of Earth's oceans combined. Europa is covered by a shell of water ice that's probably 15 to 25 kilometers thick. Beneath this ice shell is a global ocean of liquid water that might be 60 to 150 kilometers deep. If these estimates are correct, Europa's ocean contains about 2 to 3 times as much water as all of Earth's oceans combined. That's an incredible amount of water hidden beneath the icy surface of a moon that's only about 3,000 kilometers in diameter. Europa's ocean is kept liquid by tidal heating from Jupiter. As Europa orbits Jupiter, the giant planet's gravity flexes the moon, generating heat through friction. This heat is enough to maintain a liquid ocean despite the frigid temperatures in the outer solar system. The surface of Europa shows extensive evidence of this subsurface ocean. The ice shell is covered with cracks, ridges, and chaotic terrain where the ice has broken apart and reformed. Some areas show evidence of cryovolcanism, where slushy water from below has erupted onto the surface. Europa's ocean is one of the most promising places to search for extraterrestrial life in our solar system, because it has liquid water, energy sources, and probably the right chemical ingredients. Fact 73. The asteroid Psyche is a metal. World most asteroids are rocky or icy bodies, remnants from the formation of the solar system. But one asteroid is almost entirely metal. The asteroid 16 Psyche is about 226 kilometers across and appears to be made mostly of iron and nickel. Scientists believe Psyche is actually the exposed core of a protoplanet, a planet that was forming in the early solar system but was shattered by collisions before it could fully develop. When planets form, heavier materials like iron sink to the center to form a core, while lighter rocky materials form a mantle and crust. If a developing planet is hit hard enough by another large object, the outer layers can be stripped away, leaving just the metal core behind. That's probably what happened to create Psyche. This metal world is scientifically valuable because it gives us a chance to study planetary core material directly. We can't see Earth's core because it's buried beneath thousands of kilometers of rock. But Psyche is essentially a planetary core floating in space where we can examine it. NASA has launched a mission to Psyche that will arrive in 2029 to study this unique asteroid. The mission will help us understand how planets differentiate into layers and what the cores of rocky planets like Earth are really like. Fact 74. Some asteroids have moons. You might think moons only orbit planets, but many asteroids have their own moons. These are called binary asteroids or asteroid satellites. The asteroid Ida, for example, has a tiny moon named Dactyl that's only about 1.5 kilometers across. Dactyl orbits Ida at a distance of about 100 kilometers. The discovery of Dactyl in 1993 was a surprise because nobody expected asteroids to have moons. Since then, hundreds of binary asteroids have been discovered. Some asteroids even have 2 moons, making them triple asteroid systems. How do asteroids get moons? Several mechanisms are possible. Sometimes, when a large asteroid is disrupted by a collision, fragments can remain in orbit around the largest piece. Other times, a close encounter between 2 asteroids can result in one capturing the other through gravitational interaction. Some binary asteroids might form when a single asteroid splits apart due to rapid rotation. The asteroid spins so fast that material flies off the equator, and some of this material settles into orbit, forming a moon. Studying binary asteroids helps scientists understand asteroid properties like mass and density, which are important for understanding asteroid composition and for planning missions to deflect potentially hazardous asteroids. Fact 75. Comet tails point away. From the sun, when you see pictures of comets, you might notice their beautiful tails streaming behind them as they move through space. But here's something counterintuitive. Comet tails don't trail behind the comet based on the direction it's moving. Instead, comet tails always point away from the sun, regardless of which direction the comet is traveling. This happens because comet tails are formed by the solar wind and radiation pressure from the sun. As a comet approaches the sun, solar heating causes ice on the comet's surface to sublimate, turning directly from solid to gas. This creates an atmosphere around the comet called a coma. The solar wind, that constant stream of charged particles from the sun, blows the gas and dust away from the comet, creating the tail. Radiation pressure from sunlight also pushes dust particles away. Both forces push directly away from the sun, so the tail always points in the direction opposite the sun. This means when a comet is approaching the sun, its tail streams behind it. But when the comet swings around the sun and heads back out to the outer solar system, its tail actually points ahead of it, leading the way. Comets actually have two tails, a dust tail and an ion tail. The dust tail is yellowish and curved. The ion tail is bluish and points straight away from the sun. Fact 76. Io has a volcano that affects the whole moon among Io's hundreds of active volcanoes. One stands out for its sheer power. Loki Patera is an enormous volcanic feature on Io, possibly the most powerful volcano in the entire solar system. It consists of a lava lake about 200 kilometers across, surrounded by a volcanic depression. The heat output from Loki Patera is so immense that it significantly affects the temperature of Io's entire surface. When Loki Patera is particularly active, it can double Io's total heat output. The volcano operates on a roughly periodic cycle, with major eruptions occurring about every 400 to 600 days. During these eruptions, fresh magma floods across the lava lake in a process that can take weeks to months to complete. The lava temperatures at Loki Patera can exceed 1,700 degrees Celsius, hot enough to melt rock and create a glowing surface visible from spacecraft. The volcano was named after the Norse god of mischief, and it lives up to its name by being unpredictable and powerful. Studying Loki Patera and Io's other volcanoes helps scientists understand volcanic processes not just on Io, but throughout the solar system. The extreme volcanism on Io provides a natural laboratory for studying how tidal heating works and how volcanic activity shapes planetary surfaces. Fact 77. Hyperion looks like a giant sponge Saturn's moon. Hyperion is one of the strangest looking objects in the solar system. It's highly irregular in shape, looking more like a giant sponge or a potato than a sphere. Hyperion measures about 360 kilometers across its longest axis, but it's far from round. What makes Hyperion even stranger is its surface, which is covered with deep craters and sharp-edged depressions that give it a sponge-like appearance. The surface has very low density, suggesting Hyperion is actually quite porous, like a cosmic sponge made of ice and rock with lots of empty space inside. This low density, about half the density of water ice, means Hyperion might be only about 40% solid material, with the rest being empty voids. Hyperion is also one of the largest non-spherical objects in the solar system. Most objects larger than about 400 kilometers across have enough self-gravity to pull themselves into a roughly spherical shape, but Hyperion hasn't done this, suggesting its interior structure is unusual. Hyperion's rotation is also chaotic. Unlike most moons that rotate in synchronization with their orbit, Hyperion tumbles unpredictably, with its rotation axis and rotation rate changing over time due to gravitational interactions with Saturn and Titan. This chaotic rotation makes Hyperion unique among large moons. Fact 78. Bennu is so loose. You could kick a ball into space. The asteroid Bennu, visited by NASA's OSIRIS-REx spacecraft, taught scientists something surprising about asteroid structure. Bennu isn't a solid rock. It's what scientists call a rubble pile, a loose collection of boulders, rocks and dust held together by weak gravity. The material is so loosely packed that you could walk on Bennu and sink in like you're walking in a ball pit. The surface is so crumbly that when the OSIRIS-REx spacecraft touched Bennu to collect a sample, the collection arm sank about half a meter into the surface. The asteroid's material is so loose that if you were standing on Bennu and kicked a soccer ball, you could launch it into space. Bennu's escape velocity, the speed needed to escape its gravity, is only about 20 centimeters per second. That's slower than a walking pace on Earth. A gentle kick would give the ball enough speed to escape Bennu entirely. This loose structure is actually common among asteroids. Many asteroids experience collisions that shattered them, and the fragments reaccumulated through gravity, but never compacted into solid rock. Understanding this rubble pile structure is important for planetary defense. If we ever need to deflect a dangerous asteroid, strategies that work on solid rocks might not work on rubble piles. The loose structure also affects how we design spacecraft to land on or collect samples from asteroids. Fact 79. Deimos rises in the west, most moons rise in the east, and set in the west as their planets rotate beneath them. But Mars's outer moon Deimos does something different. From the surface of Mars, Deimos rises in the west and sets in the east, moving very slowly across the sky. This happens because of Deimos's orbital period. Deimos orbits Mars once every 30.3 hours, while Mars rotates once every 24.6 hours. Since Deimos's orbital period is longer than a Martian day, Mars rotates beneath Deimos faster than Deimos orbits. From the surface, this makes Deimos appear to slowly drift backwards across the sky. Deimos takes about 2.5 Martian days to cross from one horizon to the other, moving in the opposite direction from the Sun and Mars's other moon Phobos. To make things even stranger, Deimos would appear to hang nearly motionless in the sky for long periods, barely moving as it makes its slow journey from west to east. This backwards motion is the opposite of what inhabitants of most planets would see. It's a reminder that orbital mechanics can create counterintuitive results depending on the specific numbers involved. Deimos is small enough that from Mars's surface, it would appear as a bright star rather than a disk, taking over 2 days to complete its strange backwards journey across the Martian sky. Fact 80. Pluto and Charon are tidally locked to each other. Most moons are tidally locked to their planets, meaning they always show the same face to their planet as they orbit. Earth's moon is tidally locked to Earth, which is why we always see the same side of the moon. But Pluto and its largest moon Charon have an unusual relationship. They're mutually tidally locked to each other. Charon is quite large relative to Pluto, about half Pluto's diameter, making it one of the largest moon-to-planet ratios in the solar system. The two objects orbit a common center of gravity that lies in the space between them rather than inside Pluto. This makes Pluto and Charon more like a binary dwarf planet system than a traditional planet and moon. Both Pluto and Charon are tidally locked, meaning Pluto always shows the same face to Charon, and Charon always shows the same face to Pluto. From Pluto's surface, Charon would appear to hang motionless in the sky, never rising or setting, always in the same position. If you were on the side of Pluto facing Charon, you would see Charon constantly. If you were on the far side of Pluto, you would never see Charon at all. The same would be true from Charon looking at Pluto. This mutual tidal locking is the end state of tidal evolution, where both bodies have synchronized their rotations with their orbit. Fact 81. Pluto has a heart-shaped glacier. When NASA's New Horizons spacecraft flew past Pluto in July 2015, one of the most striking features it photographed was a large, bright heart-shaped region on Pluto's surface. This feature, informally named Tombor Regio after Pluto's discoverer, is about 1,600 kilometers across. The left side of the heart, called Sputnik Planitia, is a vast glacier made of solid nitrogen. This nitrogen ice is constantly in motion, flowing very slowly like ice glaciers on Earth flow, but driven by different processes. The nitrogen ice is relatively soft and flows under its own weight in convection cells that turn over on timescales of about 500,000 years. The surface of Sputnik Planitia is remarkably smooth and has very few impact craters, indicating it's geologically young, probably less than 10 million years old. The nitrogen ice accumulates on the cold surface through deposition from Pluto's thin atmosphere, and it sublimates back into the atmosphere in a continuous cycle. The heart shape appears to have influenced Pluto's orientation in space. The mass of the nitrogen ice is so large that it affects Pluto's rotation, essentially creating a gravitational anchor that influenced where Pluto's tidal lock with Charon ended up. This heart-shaped feature is one of the most unexpected and delightful discoveries in the outer solar system. Fact 82. Pluto's atmosphere. Freezes and falls as snow. Pluto has a very thin atmosphere composed mostly of nitrogen, with traces of methane and carbon monoxide. But unlike Earth's atmosphere, which remains gaseous year-round, Pluto's atmosphere freezes out and falls as snow when Pluto moves farther from the Sun in its highly elliptical orbit. Pluto's orbit is so elliptical that its distance from the Sun varies dramatically. At perihelion, closest approach, Pluto is about 4.4 billion kilometers from the Sun. At aphelion, farthest distance, it's about 7.4 billion kilometers away. When Pluto is near perihelion and receiving slightly more sunlight, nitrogen ice on the surface sublimates into gas, creating and maintaining the atmosphere. But as Pluto moves farther from the Sun and temperatures drop, the atmospheric gases freeze and fall out as snow, coating the surface. The atmosphere essentially disappears as it deposits back onto the surface. Over Pluto's 248-year orbit, the atmosphere cycles between existing as gas and existing as surface ice. Scientists observed signs that this process was beginning when New Horizons flew past Pluto. Atmospheric models suggest Pluto's atmosphere may completely collapse before Pluto reaches aphelion around 2046. This atmospheric cycle is unique to objects in the outer solar system, where temperatures hover near the freezing points of atmospheric gases. Fact 83. Pluto hasn't completed an orbit. Since its discovery, Pluto was discovered on February 18, 1930, by astronomer Clyde Tombaugh. Pluto takes about 248 Earth years to complete one orbit around the Sun. This means Pluto won't complete its first full orbit since discovery until around the year 2178. Think about that. Everyone who has ever observed Pluto, everyone who studied it, debated its planetary status, or celebrated its exploration by New Horizons, has seen it at only one part of its orbit. We haven't observed Pluto for even half of its orbital period yet. The discovery of Pluto represented the limit of what was observable with the technology of the early 20th century. It appeared as just a faint dot of light that moved slowly against the background stars. For decades, we didn't even know Pluto's true size because it was too small and distant to resolve as a disk. The discovery of its moon Charon in 1978 allowed scientists to calculate Pluto's mass accurately for the first time. Everything we knew about Pluto was limited and uncertain until New Horizons arrived in 2015, providing our first clear views of this distant world. By the time Pluto completes one orbit since its discovery, everyone alive today will be gone, and future generations will be studying the dwarf planet. Fact 84. Pluto has ice mountains as tall as the Rockies. You might expect a small, distant, frozen world like Pluto to have a relatively featureless surface. But when New Horizons flew past Pluto, it revealed a world of geological complexity, including mountains of water ice that rise several kilometers above the surrounding plains. These mountains, located at the edges of the heart-shaped Sputnik Planitia, are made of water ice, which at Pluto's temperatures is as hard as rock. Some of these mountain ranges reach heights of about 3,000 to 4,000 meters, comparable to the Rocky Mountains on Earth. The existence of these tall mountains on Pluto was a surprise because it indicates Pluto has or had enough geological activity to create these features. Mountains require a strong material to support their weight against gravity, and on Pluto, water ice provides that strength because it's frozen solid at Pluto's frigid temperatures of around -230 degrees Celsius. Nitrogen ice, which covers much of Pluto's surface, is too soft at these temperatures to support tall mountains. The mountains may have formed through tectonic processes or through the freezing and expansion of subsurface water. Their existence suggests Pluto was geologically active relatively recently in its history, perhaps within the last 100 million years. These discoveries transformed our view of Pluto from a simple frozen ball into a complex world with active geology. Fact 85. Arrokoth looks like a flattened snowman. In January 2019, NASA's New Horizons spacecraft encountered an object in the Kuiper Belt called Arrokoth, previously known as Ultima Thule. This object is about 36 kilometers long and consists of two lobes joined together, giving it the appearance of a flattened snowman or two pancakes stuck together. Arrokoth is remarkable because it's the most primitive, least evolved object ever visited by a spacecraft. It formed in the early solar system about 4.5 billion years ago and has barely changed since. The object formed when two separate bodies in the early solar system slowly came together and gently merged. The collision was so gentle, at speeds of only a few meters per second, that neither object was damaged or disrupted. They simply stuck together, creating the contact binary shape we see today. The flat, pancake-like shape of both lobes provides clues about how objects formed in the early solar system. Rather than forming through violent collisions, these objects apparently grew by gentle accumulation of material in the solar nebula. Arrokoth's surface is remarkably smooth and has a uniform reddish color created by organic compounds that have been altered by radiation over billions of years. Studying Arrokoth gives scientists a window into the conditions of the early solar system because this object has remained virtually unchanged, a fossil from the era of planet formation. Its pristine nature makes it one of the most scientifically valuable objects New Horizons has studied. Fact: 86. Pluto has blue skies. One of the most beautiful and unexpected discoveries from New Horizons was that Pluto has blue skies, similar to Earth. When New Horizons looked back at Pluto with the sun behind it, creating a backlighting effect, the spacecraft captured images of sunlight filtering through Pluto's atmosphere. The atmosphere glowed with a beautiful blue haze that looked remarkably like Earth's sky. The blue color forms through a similar process to what creates Earth's blue sky. Sunlight interacts with tiny particles in the atmosphere, and shorter wavelength blue light scatters more efficiently than longer wavelength red light. On Pluto, the haze particles are thought to be complex organic molecules called tholins. These form when ultraviolet light from the sun breaks apart methane and nitrogen molecules in Pluto's upper atmosphere. The fragments recombine into more complex molecules that clump together into tiny particles. These particles scatter blue light, creating the blue haze. Over time, the particles settle onto Pluto's surface, giving some regions a reddish-brown color. The discovery of blue skies on Pluto was emotionally powerful for many scientists and space enthusiasts. It created a connection between Earth and this distant frozen world, showing that despite the vast differences in temperature, distance from the sun, and atmospheric composition, some processes create similar beautiful results across the solar system. Fact: 87. Planet 9 might be hiding in the outer solar system, beyond Neptune and the known Kuiper Belt objects. There may be another large planet lurking in the darkness of the outer solar system. This hypothetical planet, informally called Planet 9, hasn't been observed directly, but several lines of evidence suggest it might exist. Astronomers have noticed that certain distant Kuiper Belt objects have very unusual orbits. These objects have orbits that are all tilted in similar ways and aligned in similar directions, which is statistically unlikely to occur by chance. The best explanation for this pattern is that a large planet, perhaps 5 to 10 times the mass of Earth, is gravitationally shepherding these objects into their current orbits. This planet would orbit the Sun at an enormous distance, perhaps 400 to 800 times farther than Earth, taking 10,000 to 20,000 years to complete one orbit. At that distance, the planet would be very faint and difficult to find, even with powerful telescopes. Several observatories are currently searching for Planet 9, and the search is challenging because we don't know exactly where to look. The hypothetical planet could be anywhere in a vast region of sky. If Planet 9 exists and is eventually discovered, it would be a major find, adding another planet to our solar system and solving the mystery of the unusual Kuiper Belt orbits. Some scientists are skeptical and think the orbital clustering might have other explanations, but the search continues. Fact 88. Pluto's surface is surprisingly young. When New Horizons arrived at Pluto, scientists expected to see a heavily cratered surface, a record of 4.5 billion years of impacts from asteroids and comets. Impact craters accumulate over time, and ancient geologically dead surfaces like the Moon are covered with them. But large areas of Pluto's surface, particularly the Sputnik Planitia region, have almost no visible impact craters. This can only mean one thing. These surfaces are geologically young, probably less than 10 million years old. Something has been resurfacing Pluto, erasing impact craters and creating fresh terrain. Several processes might be responsible. The nitrogen ice in Sputnik Planitia flows slowly in convection cells, constantly turning over and erasing craters. Other areas show evidence of cryovolcanism, where icy slush from below erupts onto the surface, covering older terrain. Some regions show signs of glacial flow, where nitrogen ice has moved across the surface. The fact that Pluto remains geologically active today, more than 4 billion years after it formed, is remarkable. Scientists expected such a small, distant object to have frozen solid and become geologically dead long ago. The discovery of active geology on Pluto suggests that many Kuiper Belt objects might also be more dynamic and interesting than previously thought. It raises questions about heat sources and internal dynamics in these distant frozen worlds. Fact 89. The Kuiper Belt is vast and full of icy bodies. Beyond Neptune's orbit lies a vast region called the Kuiper Belt, filled with countless icy bodies left over from the formation of the solar system. The Kuiper Belt extends from Neptune's orbit at about 30 astronomical units from the Sun, out to about 50 astronomical units or more. 1 astronomical unit is the distance from Earth to the Sun, so the Kuiper Belt occupies a huge volume of space. The belt is thought to contain hundreds of thousands of objects, larger than 100 kilometers across, and billions of smaller objects. These are icy bodies made of frozen water, methane, ammonia, and other volatile compounds mixed with rock. The Kuiper Belt is the source of many short-period comets, those comets that take less than 200 years to orbit the Sun. When gravitational interactions kick a Kuiper Belt object into the inner solar system, it becomes a comet, developing a tail as solar heating vaporizes its ices. Pluto is a Kuiper Belt object, as are Eris, Makemake, Haumea, and many other dwarf planets and smaller bodies. The Kuiper Belt represents a fossil record of the early solar system, a region where objects have remained relatively unchanged for billions of years because temperatures are so low and collisions are rare. Studying Kuiper Belt objects helps scientists understand the composition and conditions of the solar nebula from which the planets formed. Fact 90. Eris is similar in size to Pluto. The discovery of Eris in 2005 was one of the key events that led to Pluto's reclassification as a dwarf planet. Eris is a Kuiper Belt object that's similar in size to Pluto, possibly slightly larger or slightly smaller depending on exactly how you measure. When Eris was discovered, it was initially thought to be significantly larger than Pluto, which raised the question, if Eris is a planet, then why isn't Pluto? Or if Pluto is a planet, shouldn't Eris also be a planet? This dilemma forced astronomers to more carefully define what a planet is. In 2006, the International Astronomical Union created a new definition that requires planets to have cleared their orbits of other debris. Pluto and Eris both orbit in the Kuiper Belt, a region full of other objects, so neither has cleared its orbit. This led to the creation of a new category called dwarf planets, for objects that are round due to self-gravity, but haven't cleared their orbits. The decision was controversial and remains debated, but it reflects the reality that the solar system contains many objects in the grey area between small, irregular bodies and full planets. Eris orbits much farther from the Sun than Pluto, taking about 560 years to complete one orbit. It's currently about 96 astronomical units from the Sun, roughly 3 times Pluto's average distance. Fact 91. The heliopause is over. 11 billion miles away, the Sun's influence doesn't end at Pluto or even at the Kuiper Belt. The solar wind continues flowing outward until it finally meets the interstellar medium, the thin gas and dust that fills the space between stars. The boundary where the solar wind is stopped by the pressure of the interstellar medium is called the heliopause, and it marks the edge of the Sun's domain. The heliopause is located about 11 billion miles from the Sun, or about 120 astronomical units. At that distance, the solar wind, which has been flowing outward at hundreds of kilometers per second, finally slows down and stops as it encounters the interstellar medium pushing back. The exact location of the heliopause varies depending on the strength of the solar wind and the local properties of the interstellar medium. We know about the heliopause because NASA's Voyager 1 and Voyager 2 spacecraft have crossed it, entering interstellar space. Voyager 1 crossed the heliopause in August 2012, and Voyager 2 followed in November 2018. These spacecraft are now traveling through interstellar space, still sending data back to Earth, making them the first human-made objects to leave the solar system's bubble. The journey from Earth to the heliopause takes decades even for the fastest spacecraft we've built. Fact 92. Voyager 1 is now in interstellar space, launched in 1977. NASA's Voyager 1 spacecraft is now the farthest human-made object from Earth. After completing flybys of Jupiter and Saturn, Voyager 1 continued on a trajectory that carried it upward, out of the plane of the solar system and toward interstellar space. In August 2012, more than 35 years after launch, Voyager 1 crossed the heliopause and entered interstellar space. The spacecraft detected changes in its environment that indicated it had left the region dominated by the solar wind and entered the region dominated by interstellar plasma. As of now, Voyager 1 is more than 15 billion miles from Earth, so far away that radio signals traveling at the speed of light take over 22 hours to reach the spacecraft. Despite this enormous distance, Voyager 1 continues to send data back to Earth using a transmitter that generates only about 20 watts of power, less than a typical light bulb. The spacecraft is powered by radioisotope thermoelectric generators that convert heat from decaying plutonium into electricity. These generators are slowly running down, and Voyager 1 will eventually run out of power, probably sometime in the 2020s. Even after it goes silent, Voyager 1 will continue coasting through interstellar space, carrying a golden record with sounds and images from Earth, a message in a bottle for any civilization that might someday find it. Fact 93. Spacecraft face. Extreme temperature swings designing spacecraft to operate in the solar system presents unique challenges, and one of the biggest is managing temperature extremes. A spacecraft can experience temperature swings of hundreds of degrees, depending on whether it's in sunlight or shadow. In sunlight, surfaces can heat up to hundreds of degrees Celsius because there's no atmosphere to carry heat away. Heat transfer occurs only through radiation. In shadow, temperatures can plummet to hundreds of degrees below zero. These rapid swings happen when spacecraft move in and out of shadow, such as when they orbit a planet or when they're eclipsed by their target body. Spacecraft engineers must design systems that can function across this enormous temperature range. Sensitive electronics must be insulated and sometimes heated to prevent them from freezing. Other components must be kept cool to prevent overheating in direct sunlight. Thermal control is accomplished through insulation, heaters, radiators, and careful design of surface coatings that reflect or absorb heat. The challenge is even greater for spacecraft that visit multiple environments, like New Horizons, which passed close to the Sun during its Earth flyby, and then traveled to the frigid outer solar system. Managing these temperature extremes while keeping the spacecraft's instruments operational is a testament to the skill of spacecraft engineers. Fact 94. Ceres has mysterious bright spots. Ceres is the largest object in the asteroid belt and is classified as a dwarf planet. When NASA's Dawn spacecraft arrived at Ceres in 2015, it discovered mysterious bright white spots on the otherwise dark surface. These bright spots are now known to be deposits of salt, primarily sodium carbonate. The largest bright area is in Ocata crater, where the bright material covers the crater floor and appears to have formed relatively recently. How did these salt deposits form? Scientists believe Ceres has a briny subsurface ocean, or pockets of briny water beneath its surface. Impact craters can fracture the crust, allowing this salty water to reach the surface. When the water reaches the surface in Ceres's near-vacuum environment, it quickly evaporates or sublimates, leaving the salt behind as bright white deposits. The presence of these salts and the evidence for subsurface water makes Ceres potentially interesting for astrobiology, even though it's located in the relatively warm inner solar system. The bright spots transform Ceres from a simple rocky asteroid into a complex world with an active water cycle and possibly a subsurface ocean, showing that interesting geology can exist even on small bodies. Fact 95. Ceres has cryovolcanoes that erupt. Salty mud. The surprises from Ceres didn't end with bright spots. The Dawn spacecraft also discovered evidence of cryovolcanism on Ceres, but these aren't the explosive volcanic eruptions we see on Earth or even the nitrogen geysers on Triton. Ceres's cryovolcanoes erupt salty mud. The most prominent example is Ahuna Mons, a mountain about 4 kilometers high that appears to be a cryovolcanic dome. This mountain probably formed when salty, muddy material from Ceres's interior pushed up through the crust and oozed onto the surface, building up the dome over time. The material would have been a slurry of water ice, salts, and rock, warmer and less dense than the surrounding crust, allowing it to rise upward. Once on the surface, the water would have evaporated or sublimated, leaving behind a mountain made of salt and rock. Evidence suggests Ahuna Mons is geologically young, perhaps only a few 100 million years old, and there may have been many similar features in Ceres' past that have since flattened and disappeared. The discovery of cryovolcanism on Ceres indicates the dwarf planet was geologically active relatively recently and might still have liquid or slushy material in its interior. This adds Ceres to the list of geologically active worlds in the solar system, a list that keeps growing as we explore more bodies. Fact 96. Haumea spins so fast. It's shaped like a football. Haumea is one of the strangest dwarf planets in the Kuiper Belt. It's shaped like a squashed American football or an elongated ellipsoid, with dimensions of about 2,300 kilometers along its longest axis and only about 1,000 kilometers along its shortest axis. This bizarre shape exists because Haumea rotates incredibly fast. It completes one rotation in just under 4 hours, making it one of the fastest rotating large objects in the solar system. The rapid rotation creates enormous centrifugal force that pulls the equator outward, while the poles remain relatively flattened. Haumea is essentially spinning fast enough that it's stretching itself out. What caused this rapid rotation? Scientists believe Haumea was involved in a massive collision billions of years ago. The impact imparted so much angular momentum that Haumea has been spinning rapidly ever since. The collision also probably created the family of smaller objects in similar orbits around the Sun, fragments blasted off Haumea during the impact. Despite its strange shape, Haumea has enough mass and self-gravity to maintain a roughly ellipsoidal shape, which is one reason it qualifies as a dwarf planet. Haumea also has 2 known moons and even has a ring system, discovered in 2017 when Haumea passed in front of a distant star. Fact 97. Haumea has a ring system and 2 moons, in addition to its football shape and rapid rotation. Haumea has other surprising features. It has 2 small moons named Hi'iaka and Namaka, named after daughters of the Hawaiian goddess Haumea. These moons probably formed from debris left over from the same collision that set Haumea spinning so rapidly. But even more surprising is that Haumea has a ring system. This was discovered in January 2017, when Haumea passed in front of a distant star in an event called an occultation. Astronomers around the world observed the star's light as Haumea passed by, and they noticed brief dimmings of the starlight before and after Haumea itself blocked the star. These dimmings indicated something was orbiting Haumea and blocking the starlight, that something turned out to be a narrow ring of material orbiting the dwarf planet at about 2,300 kilometers from its center. Haumea's ring is the first ring system discovered around a Kuiper Belt object and only the second ring system found around a dwarf planet, after Chariklo, a smaller object between Saturn and Uranus. The discovery shows that ring systems are even more common in the solar system than we thought. The ring probably formed from debris created during impacts on Haumea's surface, or possibly from material ejected by Haumea's rapid rotation. Fact 98. Space between planets isn't completely empty. When we think of the space between planets, we might imagine a perfect vacuum with absolutely nothing in it. But interplanetary space isn't completely empty. It's filled with a thin plasma of charged particles, dust, and magnetic fields. The solar wind continuously flows through this space, carrying about 1 million tons of plasma from the Sun every second and distributing it throughout the solar system. The density of this plasma is extremely low, only about 5 particles per cubic centimeter near Earth's orbit, which is still far better than any vacuum we can create in laboratories on Earth. Interplanetary space also contains the interplanetary dust particles we discussed earlier, tiny grains from comets and asteroids. The Sun's magnetic field extends throughout interplanetary space, carried by the solar wind and creating a complex magnetic structure. Cosmic rays, high-energy particles from outside the solar system, travel through interplanetary space. All of these components interact in complex ways, creating phenomena like magnetic reconnection, shock waves, and particle acceleration. Interplanetary space is actually a dynamic, active environment studied by heliophysics, the science of the Sun, and its influence on the solar system. Understanding interplanetary space is important for space travel because spacecraft and astronauts must travel through this environment to reach other worlds. Fact 99. The solar system moves through the galaxy at over 500,000 miles per hour. We think of the solar system as our fixed reference frame. with planets orbiting the Sun while the Sun sits at the center. But the Sun isn't stationary. Our entire solar system is moving through the Milky Way galaxy at about 514,000 miles per hour, or about 828,000 kilometers per hour. The Sun orbits the center of the Milky Way galaxy, taking about 230 million years to complete one galactic orbit. That means the last time the Sun was in its current position in the galaxy, dinosaurs hadn't yet appeared on Earth. The solar system's motion through the galaxy isn't a simple circle. We also move up and down relative to the galactic plane, bobbing above and below it over tens of millions of years. This motion through the galaxy affects the solar system in subtle ways. We pass through regions of different density, encounter molecular clouds, and experience varying levels of cosmic ray exposure. Some scientists have even suggested that our passage through dense regions of the galaxy might affect Earth's climate or trigger mass extinctions, though these ideas remain controversial. The solar system's motion reminds us that even our cosmic neighborhood isn't fixed, but is constantly moving through the larger structure of the galaxy. Fact 100. Every planet has a blue sky. Here's our final fact, and it's both surprising and delightful. Based on the scientific definition of what creates a blue sky, every planet in our solar system that has an atmosphere has a blue sky, at least under certain conditions or in certain wavelengths. We've already discussed Mars's blue sunsets and Pluto's blue haze. Venus's upper atmosphere above the sulfuric acid clouds would appear blue if you could see through the clouds. The gas giants Jupiter, Saturn, Uranus, and Neptune all have blue or bluish atmospheres when viewed in certain ways. Even Titan, Saturn's moon, has blue haze layers in its upper atmosphere. The blue color comes from Rayleigh scattering, the same process that makes Earth's sky blue. This occurs when light interacts with particles or molecules much smaller than the wavelength of light. Blue light, having a shorter wavelength, scatters more efficiently than red light. Different worlds create their blue skies through different mechanisms and with different particles, but the underlying physics is the same. This commonality across diverse worlds shows that despite the incredible variety in the solar system, some physical processes work the same way everywhere. It's a reminder that we can understand alien worlds by studying the same laws of physics that govern Earth. And it creates a connection between Earth and these distant worlds, knowing that beneath different colored sunlight, many worlds share the same blue sky.